Hello everyone, and welcome to Cube Simplify workshops. I am really excited for today's session, especially. So, my name is Sam Pathak, and I am a CNCF ambassador. I work as director of technical evangelism at CIVO, and this is my YouTube channel, and we are doing Cube Simplify workshops over there. So, the idea behind workshops was to accelerate your journey in learning DevOps, in learning cloud native, especially in the Kubernetes ecosystem. I created a roadmap, in January, which is the DevOps roadmap, which was very well received by all of you, and that's the actually maximum viewed video on my YouTube channel as well. So it's a good feeling. But now half year is over. Like I gave a timeline of 6 months. Like people should be able to go through the roadmap and become job ready with their DevOps profile, at least for the internships and stuff like that for within 6 months of time period. But now the 6 months are over. We are in July. We are in the second half of the year. So if you think that you have wasted half year, or you didn't get time to start, or you were stuck somewhere, or you had the resources but wanted something to go through it, go with you, somebody telling you stuff how to do it. So that is the reason Cube Simplify workshops have are here now. So, as part of these workshops, we'll be covering from the start. So, as you know from the topic itself, this is Linux and Docker fundamentals. So, this is a fundamental workshop to build your base. And slowly, we'll move on to all the other steps with Kubernetes, Kubernetes monitoring, Kubernetes security, Kubernetes chaos, service mesh. So, we'll be covering all these domains. So, you need to kind of keep an eye on cubesimplify.com/workshops so that you do not miss any workshops. Yes, you always have to register for the workshops, but when the workshops are going live, you are feel free to share the links so that other people can also join. Feel free to ask the questions in the chat. So there are moderators, around seven or eight moderators who are moderating the chat. Please do not post anything offensive and adhere to the code of conduct. Please maintain be respectful to each other. We are here to learn, so let's make it fun and enjoyable, not making any comments and things like that. And for obviously people are there to moderate the chat. So if you do, then obviously it will be deleted, and you will be kind of removed. But I really hope, like, you are here to learn, so let's learn together. And make sure to join the Discord. So I think YouTube chat will be having a limit to ask the questions, so in terms of characters. So what you can do is, if you have a big question you want to ask, you screenshots you want to share, something is not working, join the workshops channel in the cubesimplify.com/discord, and which is displayed on the screen right now, so you can see the banner, cubesimplify.com/discord. Join it and go to the workshops channel, and there you can carry on the discussions, what is working, what is not, share the screenshots. And our ambassadors are there, Cube Simplify ambassadors, who are moderating that as well, and they'll be able to happily assist with any of the things which are not working. So yeah, those were some of the kind of stuff that I wanted to talk before we get on to this particular workshop. And make sure to follow. Let me pull up the banners. So this workshop is, yes, Linux and Docker fundamentals. Make sure to follow Cube Simplify on Twitter. Those are the mandatory stuff that you should be doing. Make sure to follow me on Twitter as well, and make sure to subscribe to the channel, because I think only then you'll be able to ask questions. I have done that sort of setting somewhere in the live stream. So subscribe to the channel, share it as much as you can. There are tons of cloud native stuff on the channel, and you can now share this link that you have received within your network as well, so that other people can also join. But I see a lot of good audience, enthusiastic audience is already there to learn. So without wasting any time, I would like to introduce my very good friend Chad. So Chad, first of all, thank you so much for agreeing to take this workshop. I know it's always hectic to do a hands-on workshop, so many things to cover, what all to tell to the audience, especially when you have to set the fundamentals right. So people are expecting a lot of good stuff coming on this workshop, and I can assure you that Chad is the perfect person doing this workshop. And I reached out to him. He said, let's do it. You are doing great for the community, so thank you so much, appreciate it, you coming on this workshop, and so excited to have you. Before you start, please can you introduce yourself a bit to the community?
Yeah, thanks for having me, Sam. I really appreciate it. Yeah, when you reached out, I was more than happy to come on and teach this class. It's a small passion of mine, teaching. You may have seen me before on A Cloud Guru and Cloud Skills and all around the web trying to teach everyone these fundamentals that we'll learn today. And my favorite way of learning is by doing. And so I'm really excited to get some hands-on work with you here today, and we'll have some fun. So again, my name is Chad Crowell, and I have been a trainer for some years. Right now I'm a DevOps consultant, and yeah, just have a passion for teaching and learning new things. And like Kelsey Hightower always says, learning in public. You know, try to learn in public, and that's to me the best way to learn, and also benefits everyone around you. So I'm really excited to dig in today. So let's do it.
Absolutely. So the stage is all yours, and let me know when you want to share the screen.
Okay, let's do it. I'm ready. All right, can you see my screen here? Looks
Yes,
like you
we can.
can. So
Yep.
as I said, I am an instructor slash consultant. I specialize in DevOps, containers, and Kubernetes. I have a book in early access right now through Manning called Acing the Certified Kubernetes Administrator Exam. And if you're interested in taking the CKA exam through the Linux Foundation, I would highly encourage you to pick up that book. I have a discount code if you'd like, and would love to help you along your journey to pass that exam. Check me out on the socials, on YouTube at Chad Michael Crowell. That's what the M stands for. And then all other socials, I'm just Chad M. Crowell. And yeah, if you like this presentation by the end, just go ahead and smash that like button, as they say, and go ahead and give a follow. Appreciate it. So a little preview of what's in store today. We're going to be going through, obviously, Linux and Docker, but we're going to weigh a little heavier on Docker, being that it's more pertinent, I guess, in the DevOps tool set. And we'll give you a lot of advantages in terms of working with containers, seeing the advantages of containers. And the Linux portion is more or less to support the Docker part of this fundamentals course. So the Linux, obviously running containers on Linux is, it utilizes a part of the Linux operating system, and we'll get into that in a little bit. So we'll talk about all these things from virtual machines to SSH to processes to Docker files to Docker Compose and all that stuff. So I'm really excited to dig in here. And like I said, we're going to be learning by doing, which is my favorite way of learning. So it's going to be less of these slides that you're seeing here and more operating in the terminal. And I encourage you to follow along. So with that being said, let's go ahead and open up our terminal. And the nice people over there at Killer Coda have offered up a free lab environment for us to use. And so I encourage you to go to killercoda.com. And if you don't already have an account, go ahead and sign up. It's absolutely free. And you can get access to a terminal just like you see in the lower right-hand corner. And we'll go through this learn by doing journey together. So just in case you're unfamiliar, I'm going to switch over to my terminal now. Sorry for the inception there. So again, we're going to go to our web browser here and go to killercoda.com. And let me log out and log back in just so you can see what the experience is. So this is what you'll see when you click on login. For me, I use GitHub. You can also use GitLab, Google, or emails as a part of logging in. And if you don't already have an account, you can quickly create one. It just uses the credentials that you have, being your name and your email address from either Google or GitHub or whatever link you clicked on there. So once you get access to the available labs, we're gonna take a shortcut here, and in the navigation bar or the address bar, we're gonna type in killercoded.com/areas/scenarios/Ubuntu. Let's see, so, oops, sorry. So it's killercoded.com/playgrounds/scenario/Ubuntu, my bad. So we'll put a link in the chat to that if we haven't already, and then you can follow that link and make sure we're all set to go here. So killercoded.com/playgrounds/scenario/Ubuntu. Yeah, just want to wait a second for everyone to get caught up here. And while everyone's getting caught up, let's go ahead and go back to the slides for just a second. And if you see in the lower right here, we're running various commands and getting output. And so let's talk about that a little bit. So I forgot I put this video in here. So if this is just a short clip of Richard Stallman talking about kind of installing your own distribution. So I was going to make a joke of, we're not going through the process of installing our own distribution here, just because Richard Stallman, as he says in the video, I've never installed GNU such Linux. So it's a funny video if you want to watch at your leisure there. So let's talk about what we'll go through in the Linux portion of this. So we're going to talk about the Linux operating system and the file system. So we'll get into what is comprised of Linux operating system, what an operating system is if you're not familiar, and then go through what is comprised of what kind of things that you'll find in a file system inside of Linux. Then we'll go through some basic commands. So we'll go through how to navigate the file system, how to start up your favorite programs, what that looks like in the background. Then we'll go through packages. So packages are a very important part of installing software in Linux. So we'll go through installing software with a package manager. Then we'll go through creating files and editing files in your favorite text editor. My favorite text editor is Vim. And then we'll go through permissions and talk about what is required in order to get access to certain directories and certain files, and what permissions look like in Linux. And then we'll go through redirects. So redirecting your input to output. And so as you saw in the previous slide, there's a number of various outputs that you can get in the Linux terminal, and how do you redirect that output to a different place. Then we'll go through services. What are Linux system services, and what do services do? What are daemons, and how does that relate to the services that are running on our computers and our Linux systems? And then finally, we'll go through Git. This is a lot to go through. I know that we said we have more in store for Docker. We do have quite a bit of content to get through here, so let's go ahead and get through it. So at any point in time, feel free to ask questions. I am going to be going rather fast, so don't hesitate to put any questions in the chat, and I will get to them as we go here. And the idea of having this in a live session here is that you can ask questions and you can get more clarification on some of the things maybe you don't understand, and that helps us all, right? There's no dumb questions, so please feel free to ask as many questions as you can. So let's get into the operating system, the Linux operating system. The operating system, obviously, it's essential for running and interacting with the components of your computer. You know, without an operating system, we wouldn't be able to use a keyboard and mouse. We wouldn't be able to have a GUI, and we wouldn't be able to point and click, and we wouldn't be able to use our terminal. So it's the interaction between the pieces of our operating system that allow us to use our computer and to use things like you're seeing today on your operating system, whether it's Mac, Windows, Linux. The operating system is what provides us the ability to go to the web and attend a webinar such as this. So various distributions, they're called distributions, by the way. So and it's just a different variation of the operating system. So different variations of the operating system include Ubuntu, Fedora, Arch Linux, OpenSUSE, and Debian. So those are the most popular distributions out there, which is just a different flavor of Linux. So all of the stuff that we'll be going through today is uniform between all of those distributions, but just know that these different flavors exist. Some of them have different package managers. Some of them have different ways of operating. For the as you saw, as we typed into the web browser, we're going to be using Ubuntu. And so that's just a very popular distribution for the web, and easy to learn, easy to navigate. So that's what we'll be using for this portion of the workshop. So let's go through what is comprised of an operating system. And if you're following along here and you've gotten access to your terminal on the Killer Coda site, we can switch back over there real quick and we can run the same command, which is ls, and then a /, which represents the root operating system, or the root file system, I should say, sorry. So the root file system is comprised of all of these different directories, and the ones in light blue are symlinks, so that's a link to another directory. And then you have these directories and also files that have certain permissions. So can you access this as a regular user versus root user? And we'll get to that in another slide. So just to go through the contents real quick, the boot directory is the essential files to boot the system. And by the way, if you haven't kind of gathered this already, Linux is just a series of files, and sometimes those files interact in a certain way to do special things. But essentially, if you're taking notes, just write down Linux is nothing more than just a group of files. And so that's very important to remember, and will kind of carry us through the general theme for this workshop, and I believe add a lot of benefit in being able to understand, okay, we're just working with files here. It may be a certain command that tells us to group of files in a certain way, but the Linux operating system is just a grouping of files. So moving on to the dev directory. So the dev directory are the device configuration files, like the keyboard and mouse, that allow your computer to interact with those peripherals. So printer, keyboard, mouse, USB drives, and all of that gives the drivers behind those certain pieces to interact with your operating system. Next is the etc directory. So we have the system-wide configurations. So this is the configurations of everything on your system in terms of how it works. You'll find a lot of the like the host name information, the fs tab, which are the file systems that are introduced to your operating system. And so you'll find all that in the etc directory. The home directory is where everyone's home directory is. So by default, when you log into your Linux operating system, and if we switch over to our Killer Coda session here again, we can see that if we type in pwd, which stands for present working directory, we'll see that we're in the root directory. And once we get to creating users, we will see a lot of different folders popping up in the home directory. So right now we have an Ubuntu user. So that is the default user for this particular lab. And we'll get to creating new users in a minute here. So that's the home directory. So the media directory, I'm going to skip down a few because I just want to go over the ones that are common to a Linux operating system. And a lot of these are extras that you'll find in certain distributions. So I want to go through things that are, make sense for, being able to connect the dots in terms of what an operating system is, but also, being able to find the commonality between all Linux systems. So the media directory is the device mounts like CD or USB thumb drive. So this is what allows you to see that media, be able to browse through it, be able to view the contents of that USB thumb drive or CD. The mount directory is a temporary mount point for added file systems. So you have like all the different file systems that we have, like NFS or CIFS or what have you. And then we have the app directory, which is for programs that install binaries and libraries in one directory. So if you have a piece of software that's built for Linux, usually that piece of software will be distributed throughout multiple directories in your file system. So usually it's the /bin folder, and the which is, as you can see, is symlinked to the user bin folder, and then other directories throughout that will provide a certain functionality. And that's usually how software is built that's built for Linux, the Linux operating system. But sometimes you have software that contains a single binary, or contain the packaging up of that software is directed towards one directory, in this case, the op directory. That's where that usually lives. Moving on to the proc directory. This represents the current state of the kernel. So this is the kernel information. If you want to see all of the kernel information, such as how the kernel is structured, all the processes, the proc directory is where you would go and find that, and be able to dig down into modifying the kernel if you wish. Because as we know, Linux is open source, so you can you can create your own. You can create your own distribution of Linux if you wish, and the modification of the kernel is totally, the kernel is open source, therefore you can make of it what you wish. Moving on to the root directory. So root is a special user in Linux, and we'll get to using root and kind of elevating our privileges in a little bit here, but just know that root, not only are we in the root directory of our file system, but we have a special user called root that has permissions to do anything on our system. And by default, we usually want to lock down or disable the use of root for normal users, because that root user can do anything, and which opens up a whole can of worms in terms of allowing access to things. And you can really get into a lot of trouble when either using root when not really knowing what you're doing, or when giving other people root access. So that's very important to know that root is a special user. Moving on to the run directory. The run directory is a temporary runtime for files. So as we talked about before, when you build software, you build it in a way that spreads those groupings of files. Like I said, Everything on a Linux system is just a group of files. Spread those files. Sometimes some of those files end up in the run directory. The snap directory, now this is not common to all Linux systems, but can be. Snap is another package manager that sometimes is preferred because you can install this package manager on top of your Linux distributions, as opposed to getting used to using the individual package managers. And we'll get to talk about package managers in a little bit here. So the package manager for Ubuntu is apt. The package manager for Fedora is yum, and so on and so forth. And there's different package managers for all different distributions. So next is the SRV directory, and contains specific site data. And site data, like you are working in a certain location, geographic location that is, and just information about where your computer is in the world, maybe IPs, DNS, and stuff like that. The sys directory is for the virtual file system, for viewing the kernel. So this is also another directory for viewing kernel information and may be useful for that. The temporary or TMP directory is for temporary files. And the user directory or the USR directory is for user binaries and files. And then finally, the var directory is for variable data like logs. So you'll find var/logs. Anything under var is pertinent to temporary data, but a lot of times will contain logs. All right, so the fun part, let's get into going through the first bit of learning by doing and get into some hands-on learning and hands-on work here. So I have 4 different scenarios that we'll be going through together. And through that, we'll be learning a little bit more about the Linux operating system and the file system. So number 1, we'll be going through a task together that includes getting the OS info. So how do you get information out of your operating system? And more specifically, how do you get back the CPU and RAM information, and what is being utilized, how much RAM do you have, how much CPU do you have? Number 2, the scenario that we're going through is finding out where syslog is on a Linux system. Syslog is an important location for all the system logs, and so we'll be looking at that and seeing what that looks like. Our third scenario that we'll be walking through together is creating a new user, and we'll be using the bash shell, which we'll be talking about as we go here, and configuring the bash shell as their default shell. And then finally, we'll be creating a new group. So a group in Linux is just a grouping of users. So that group can have certain permissions on a Linux system. And so we'll be creating a group, in this case, a group for Docker, because we'll be using Docker later in this workshop. And so we'll go through, creating a group and then adding our new user. We're going to name this user Chris, and we'll be adding Chris to the Docker group. All right, so let's switch over to our terminal once again, and we'll be going through this together. So please follow along as we go through these scenarios together. All right, so we've already run a few commands together, such as ls and pwd. And as we said, ls, or maybe I didn't describe, ls allows us to view the directory. So it's listening the contents of that directory. And then pwd is getting our present working directory. So what directory are we in currently? In order to change directory, before we get into the first scenario here, I think this is important to go through some kind of fundamentals here. So in order to change into a different directory, so right now we're in /root, for example. In order to change into a different directory, we use the cd command, so change directory. and we can change directory into the root file system and then list the contents of that directory using the ls command. And these are all the directories that we just went through. And we talked about what all of these directories are used for and what will be inside of those directories usually. In order to get to the top of my screen, let's say I wanted, to make all of this output vanish. I can use the word clear to clear my screen. So that gets me back up to the top of my screen so we can kind of start fresh and start issuing new commands. So that's the ls, cd, and pwd commands, which are very essential for going through a Linux file system. Let's find the information, which is a part of our first scenario. So let's find out different information about our system. And on a Ubuntu distribution, you can find out information in a lot of different ways. One way is, which is the way that I use a lot, is lsb_release. So if you're following along, please go ahead and type in lsb_release, and then a space, and then a -a. And -a is just a flag. And we'll learn about flags as we go here, which is a good way to filter through some of the options in our commands, such as lsb release, and be able to get certain output. And a lot of times, if you don't know the flags, let's say you didn't know the -a, you can use what's called the man pages or the manual pages. And in order to access the man pages, you just type in man and then lsb release or whatever command you're planning to run. So these are what's called the manual pages or the man pages. And this will get you lots of different information about what this command does and all the flags that are associated with it. So as I scroll down here, I'm just pressing the down arrow on my keyboard. You can go through, if you do lsb-v, lsb-i, lsb-d, and so on and so forth. So as you can see, the -a is what we used, displays all of the above information. So it displays everything about the release of our distribution. A lot of times the Ubuntu or whatever distribution you're using, Fedora, Arch, these are, this is the release information. So the release of the particular distribution. You may get a release that's 14.04 or 16.04 or 18.04. These are different releases, just as you would update your operating system, whether that's Mac or Windows. The various release information is what is comprised of that particular version of the operating system that you're using. And so yeah, that makes sense, right? Like it's a release of a particular distribution of an operating system. If I wanted to search the manual pages, I would just type in the /, and this is very common in a lot of text editors, but as well as the man pages. So I can just search through this, and let's say I wanted to search for --all. So I can just type that in after the /, and then I can hit enter on my keyboard, and then it just searches through all of the manual pages and highlights what I've searched for. In this case, it's all, so it's highlighted all, and that's how I get that information. To exit out of the manual pages, all I have to press is Q. So I pressed Q on my keyboard, and now I have exited from the manual pages, and now I'm back to my terminal, and we usually call this a prompt, a terminal prompt, in which we can start issuing more commands. So back to the lsb release command. So we found out, due to the A flag releasing all of the information about our release, we found out that we're running Ubuntu, the 20.04.3 release. And LTS stands for the lifetime support, or the lifetime support of Ubuntu. That means that it's a stable version, and it's safe to use in a lot of ways. So a lot of people are using this LTS version of Ubuntu to provide stability for their applications. Maybe they're developing applications or what have you. And so this provides a good indication that, yes, you are using a distribution that has been tried and true, has been tested thoroughly, and you should feel comfortable with using this particular release of Ubuntu. And the code name is Focal. Focal is a lot of well, it's a nickname, a code name. So a lot of times you'll ask, what's your favorite distribution? And say Ubuntu, and they'll ask, what is the what version of Ubuntu? And you say Focal, or it's just a common name, just a short name. So anyways, let's go to a different way of getting information out of our operating system, and that is to cat. So I'm using the cat command. Again, we can do man cat and find out the manual pages for using the cat command. But I'm going to cat out, which means to display an output to the terminal, the etc os-release. So type in cat space /etc. I usually call it etc, so interchangeable there, /os-release. And that gets me a little bit more information, right? So I can find out the home URL, the support URL, the bug report URL, all this additional information that I didn't get with the LSB command, the LSB release command. So that's just catting out a file. Like I said, the operating system is just a grouping of files. That's just catting out one of those files in the etc directory or the etc directory, which is very important for finding out OS information, or the release information, I should say. So I'm going to go ahead and clear my screen. Hopefully you're catching up with me here as we're going through these commands. And another way of getting out information is to use uname. So uname, again, we can do man uname, but we won't for the, you've gone through that enough times, I think. Uname -a, and we can get out another kind of output of what our system information is. So this time we get out the time and the date and the x86 64, so 64-bit operating system, and we're using GNU/Linux, which is very important. And then another way is to do ls-cpu, which gets us a lot more information in terms of our CPU. So if we scroll up a little bit, we can find out that we have the model 42. The model name is Intel Xeon E312. We can see that there's one CPU. So there is one thread per core. Again, it's a 64-bit system, supports 32-bit as well. And a lot of information here that may or may not be important in terms of getting CPU information. So what chip architecture, or what is the chip information or the CPU information for a system? That's very important. So again, that's ls-cpu. ls-cpu. Another way of getting out the memory information, or the RAM, is ls-mem. So this will tell us the memory block size, the total online memory, and the offline memory. So this is a good way of seeing how much RAM you have available. RAM stands for random access memory, if you don't know, and this is what controls the running of processes on our system, or running certain applications on our system, and it's a way for our system to allocate all of that memory, or I guess the things that you see on your screen, the display of that information right front and center. So if you're using your text editor, the text editor is what is consuming the RAM at a given time. If you're using another program, the RAM is being consumed by that, and it allows you to get information back from your system a lot quicker, being that it's It's not going back to disk to access it and then coming back to the screen to display it. So random access memory is our RAM, is what we use to utilize some of the multi-program features, kind of what we're getting out of the programs that we're using on our system. Okay, so that completes our first scenario. So let's go on to the second scenario, which is finding the syslog in Linux. So the syslog, again, is an important directory, or important file, I should say, that contains all of our system information. The logging, which is just an output of lines of text, the logging of our system telling us what the system is doing at any given point in time. So a lot of times it will contain information about memory or CPU, or maybe you have a program that's not operating correctly, so you'll get error messages in there. So you'll want to look at that for troubleshooting and finding out if any problems are going on inside the operating system. So system log. So we can go through and find the system log either by changing directory to that file, if you know where it is, or we can use something called the find command. So the find command is just as it sounds, it's for finding files on our system. So we can do man find and check out what is the find command and how do we use it. But in this case, we'll just do find and then /, which stands for the entire file system. So / again is our root directory of our file system. And then -name, which will specify a name for the file that we're looking for. So find something with the name of syslog. And I put syslog in quotes just because it's an exact name. I know exactly what that file name is. So I'm going to put it in quotes because I want to be specific. So on our system, it returned 3 results. So that's great. So we have syslog in /run systemd journal syslog, user local go source log syslog, and then var log syslog. Var log syslog is what we're actually looking for. So we'll go ahead and change directory to var log. And then we'll list the contents of the var log directory, and we'll see there it is, syslog. So let's go ahead and open this in our favorite text editor. I am cheating a little bit. I'm getting ahead of myself because we're going to be talking about text editors in a second. Or we could cat it out, I suppose. But actually, let's do that. I don't want to get ahead of myself. So let's talk about Vim a little bit later. I get excited sometimes, sorry. But let's talk about catting out the syslog. So I'll just type in cat space syslog. Whoa, that was a lot of information. So how do I view this information in a better way, as opposed to spitting this out so that I have to scroll up and down to search for whatever I'm searching for? Or, maybe I'm troubleshooting the system, so I need to find out what the error messages are. You can make this a little bit easier. Let me clear the screen so I can get to the top. And so I can run that same command, and I can navigate through my commands, by the way, by just pressing the up arrow on my keyboard. So if you press the up arrow on your keyboard, you can go through the list of commands that you've previously run. This is also, there's also another way of getting commands that you've previously run, and that's just by typing in history. So by typing in history, you can get a good view of what commands you've run in the past. That could be helpful if you're trying to document something, or maybe you're trying to look for a certain command that you've run in the past. Maybe you can remember that command. And so history is a good way to review that. All right, back to syslog. So I can run cat syslog. I'm just going to hit the up arrow until I get to that command that I ran before. So cat syslog, being that we're already in the var log directory, we can just type in syslog. And then this is the piping information that we talked about before, or that I alluded to before. So this is called a pipe, and it's just above the enter key on the keyboard, it's just a line straight up and down. Above the enter keyboard, on my keyboard at least, you can see the up and down line. We call that a pipe. A pipe. So we're going to pipe something to another command. So I alluded to before being able to take the input of something and pipe it to the output of something else. So in this case, we're gonna take the input of cat syslog and we're gonna pipe that to something else. In this case, we're gonna pipe it to less. Less is another command that we can run to view our files in a more manageable way. And if I just run this, you can see I only have the beginning of that file. So I no longer have to scroll up and down to view that file. I can now go through it in an appropriately sized window view. And I can press the space bar to go through that file line by line. And it's not necessarily going line by line, it's going frame by frame. The frame being the amount of lines that's able to fit in the screen. So I can continue to press the space bar. I'm just pressing the space bar over and over again. If I got tired of using the space bar, or maybe I found something that I was looking for, let's say I was looking for private test. I could say, okay, I found private test. I'm gonna take that and copy it out into something else, or I can just press the Q key on my keyboard. So Q, and much like the man pages, I can just quit out of my out of that less function. So the less function is very important for being able to read files from top to bottom. Also, there's more. So this is the same idea. So I can press the space bar to go through the file in the same exact manner. So less and more. And again, we're just piping things from the input and then outputting them to the less or more command. All right, so we've viewed the syslog file and we've viewed all. One more thing I wanted to cover related to the syslog is, and we'll get to use this a little bit in the coming scenarios, but we can also do something like this. So we can cat out the syslog, but also let's say we wanted to search for certain things in that file. Like I said, we can use less to go frame by frame to try to use our eyes to, see what's in that file and try to pinpoint certain things that we're looking for. Or we can use a search functionality that's already built into all Linux operating systems. And that search functionality is called grep. So grep, and we'll get to using, we'll use this another time in a few more scenarios, but I get so excited about grep because grep is a really good tool for searching through files. So I can grep and I can search for anything I want. So I can search for error, or I can search for Ubuntu, and I can get the results. See, the results are in red, so that makes it easier to see. So grep is a really good tool for searching through files, especially really long files like syslog. All right, so our third scenario that we're going to go through together is creating a user. Very cool. So creating a user is very simple in Linux. And we can, again, so let's see. So adding a user in Linux is as easy as issuing the command user add. If I can type user add. So if you're following along, type in user add, and maybe you want to check out the manual pages for user add. You can do that too. But user add is very important for, you guessed it, adding users. So we're going to add the user Chris, but first, let's check out some other cool things before we do this. So if you checked out the man pages for user add, there's an option, there's a flag, as we say, -D. And -D allows us to output the information that is default for all users. And you notice, here's the default group that users are put in when they first get created. Here's the default for where their home location is. Here's the default for which shell they're going to use, so on and so forth. So you can get an idea for what are some of the defaults that are going to be placed upon a user automatically when you create that user. So if you wanted to change this information, so my preference in the type of shell that I like to use is called the bash shell. Again, this shell that let's echo, and echo is another command that we can use to echo an environment variable, in this case, the shell environment variable. Please ask questions if I'm going too fast here or if you're not understanding. I do have one question. So sorry I skipped over this, but we do have a question. Is it Linux's job to talk to the kernel? If so, how does the terminal talk to the kernel? So yes, it is. I mean, Linux is the kernel, right? So the kernel is the fundamental layer that is interacting with the hardware on your machine, whether it's your laptop or the server or wherever. The kernel is what allows you to use your machine. You know, being that it's just a machine, it just talks in ones and zeros. So in order to translate that, we have the kernel to translate the commands that we're running in the terminal to whatever hardware functionality we want to get out of our machine. What hierarchy do these directories follow? Like, is there a tree-like image for this? So yeah, I think I explained that before. Sorry again if I missed that question, but yeah, the tree-like structure that you're thinking of is the file system in that it's structured in a hierarchy or a tree where the root is at the bottom, and if you picture an actual tree, the root is at the bottom, and if you go up the trunk of the tree, you'll notice that all of these directories split off into different branches. You can think of the directories as branches, and then there's directories under that, and then there's directories under that. So the tree gets bigger and bigger as we go through the file system. And it's actually so it's actually there's actually a tree command that we can run. So if we were in a certain directory, so if we change directory, if we just use the cd command, we can go back to our home directory. And in this case, because we're the root user, we're in the root directory because that's the special directory just for root. We can run the tree command to get a view of what our tree looks like. Actually, sorry, I got off on a tangent here. Let's go back to creating a user. Once we've created the user, I will show you about the tree command and explain a little bit more about the tree structure of the file system. So there's a question that came in. It says expire is not assigned to any value. I'm not sure what expire means. If you could explain that, that would be great. And then I will answer your question. All right, so the shell that we're using in this particular case is bin/bash. If you see that when I echo shell. So bin/bash, what does that mean? So a lot of times how we interact with the kernel, how we interact with our operating system is through the command line and through the terminal like we're doing right now. And in order to have certain things interpreted certain ways, we use a shell. This shell can come in many different flavors as well. So we have the born shell, the born again shell, the corn shell, lots of different, the ZSH shell. So there's a lot of different shells that you can use, which are just different types of ways that you can use the terminal to interact with the kernel, but are depending on your preference, you know, is just whatever you're comfortable with, allows you to use certain commands to do certain things. So in this case, we're using bin bash, which is the born again shell. And this allows us to use certain language like echo, like cd, like pwd, to interpret certain things to the kernel. So my favorite is the born again shell, so bin bash. And it's very common, probably the most common is the born again shell, and allows us to do as we're doing now, which is input certain commands, and we're getting certain output. And so if we wanted to change that, as we saw from the default that gets created when each user is created, it's the born shell. That's this right here, bin-sh. That's just the born shell. We want the born again shell, which is kind of an improvement of the born shell. We could go on a tangent on all the things related to shells, but we won't for the sake of time here. So if I wanted to change that, all I would do is issue the user add command again and the capital D, just as we did above, and we can change it by using the -s flag. So -s, and then specify the shell that we want to use. So bin bash. So once we do that, and if you're following along, again, it's user add space dash capital D space dash s, lowercase s, space /bin/bash. Okay, so now let's clear our screen and we'll do the user add. This is a previous command, and instead of trying to hit the up arrow until I get to the command, there's actually another way that I can search for commands really easily. Maybe it's like a command that I ran a couple days ago. It's like, yeah, I don't want to sit here and just keep going through and searching for it by pressing the up arrow. I can actually use the key combination Control-R, and I can search for that command. So I can do user add, and then this is the command that I just previously ran because it's going to output, or it's going to search for and give you the results for the commands that you issued first. I can press the Control-R key combination again, and I can get the previous command. So user add space -d was the previous command that I ran, which was a part of the user add kind of search that I did using the Control-R. And then I just pressed enter to run that command again, which is so convenient. I use that every day, so many times, it's not even funny. I use the it's Control-R on your keyboard, key combination, in order to search for different commands that I've run in the past. So it's very useful. And then if I don't necessarily find if I don't necessarily get the search results that I was looking for, I can keep on pressing Control-R. So I can keep pressing Control-R until I find it, which is very useful. And okay, so now we've changed the default shell for all new users to bin bash, which is what we want. And so now we can get to creating our user, because we don't want to shortchange this new user, this Chris user that we're going to create. We don't want to shortchange him and give him, we don't want him to have the born shell. We want him to have the born again shell. So let's do a user create. Okay, so actually it's user add again. So again, we can, sorry, I'm just kind of going through my notes here, and we did the echo shell, right? So echo, another way of doing that is echo the, so echo space $0, and we can also get out what type of shell that we're using. So that's another way of doing that in tandem or in replacement of the echo shell. I could also cat etc shells to get what shells are available. So these are all the shells that I could potentially switch to if I wanted to. So that's a little bit about shells. again, just the $ shell is an environment variable. If I echo that out, echo is another kind of not a replacement for cat, but another way of outputting those environment variables. And echoing, you can echo anything. You can echo a string, you can echo a number. It just a lot like it sounds, it's echo. So a lot of these environment variables come right out of the box with Linux. And if we wanted to view these environment variables, we can just type in the env command. So again, that's env, and we can see all the environment variables that are available. And if we search through here, and we have to get our uppercase and lowercase all situated. So we can see if we grep the env, we can see we have the bin bash, just like we did echo shell. That's how we echo that out. So that is the environment variables. We can also do print env to print them out to the screen. It's the same thing. So that's environment variables in a nutshell. Those are just kind of just like any variable, just a variable that you can set on your system to kind of either point to a certain file or point to a certain string, or kind of be in place of, just like a variable does, be in place of something meaningful that you can use later on to refer to. All right, so sorry about that tangent again. I just get so excited. Let's go ahead and create our user. So user add -m, and -m just creates a home directory for the user that we're going to create, which we'll name this user Chris. And you can name this user wherever you want. You can name it your own name if you'd like. You can name it anything. But I'm going to use Chris. All right, so I added the user, but the user doesn't have a password, so we can't switch over to that user because we don't have a password for the user. In order to create a password for a user in Linux, we use the command passwd. And so I can do passwd Chris to set a password for Chris. So let's just do a password real quick. And now we have created the user. We've created a password for that user. And now we can go ahead and switch over to that user. But first, let's talk about sudo. Okay, so sudo is kind of like if you're on a Windows system, when you right click and you run that as administrator, you kind of elevate your privileges temporarily so that you can act as the root user. And we call that sudo. So sudo is a way to elevate your privileges so you can have more privileges than your user usually allows. And we use sudo a lot to install applications, to gain access to files. A lot of times, if we're looking at the syslog, we want to type sudo because the etc directory is only accessible by default by the root user. So we use sudo to elevate our privileges so we can see the syslog, or to see anything in the etc directory. Okay, so now that we've created the user and created a password, let's go back to that question that was in the chat. Sorry. So I asked, let's see. So expire is not assigned by any value. I don't understand what that means. I'm sorry. Can you explain a little bit more detail about various default values of user add? Okay, so default values of user add, there's no real default values of user add besides the ones that we already explored. But if you wanted to learn more about what you can do with user add, you can do man user add. And you can go through the manual pages and see all the different options. You can do a default base directory for the system. You can do a comment. You can do specify a certain home directory. Maybe it's not home. Maybe you want to put the home directory in the root directory. That would be crazy, right? Maybe you want to set certain defaults. All right, so yeah, changing default values. So the ones that we just we did the defaults from before. We already talked about that, so we'll skip that. Expire date, inactive, so on and so forth. So I won't spend too much time on that because you yourself can go through the manual pages if you want. Okay, so the question is, if you type in user add -d, there's a section named expire. Okay, so let's explore that a little bit. User add d expire. Okay, maybe they're referring to the expire. What is the expire? Ah, okay. Does that mean it will never expire? Yeah, it's for the user. It's when the user expires. So you can set temporary users. So if you set this expire to 30, let's say, it's going to be a number of days. So this user account, if you will expire after 30 days. So yeah, expire means how long this user will be valid for. So once those 30 days, let's say, expire, you can no longer use that user. So that's what expire is. Okay, cool. I know expire means now. So thank you for clarifying that. And let's get back to business. So now that we know a little bit about sudo, let's add our, so a lot of times we have to add our user to certain groups so that they can do certain things. So in this case, we're gonna add our user to the sudo group. So to use that, to do that, we're gonna do user mod. I shouldn't talk and type at the same time, it's bad. And then using the flag, lowercase a and capital G, sudo, which is the group that I want to add Chris to. So again, it's user mod. So I'm modifying this user in a way that's adding this user to the sudo group. This means that they can run sudo commands. So sudo commands are very important for, again, installing software, gaining access to the etc directory or any other directory in which only the root has permissions to access the directory. Installing is a big part of it, which we'll go through in a little bit here when we talk about package managers. But we're just adding this user to the sudo group so that we can do that when we've switched over to that user. So now that we've talked about sudo, we've added Chris, our user, or whatever user you created, to the sudo group. We can go ahead and switch to the Chris user. And so I know, if you see on the left-hand side here, our environment expires in 4 minutes, okay? So if your environment expires, you can just hit the refresh either in your web browser, you can hit the refresh to just refresh the screen, or you can click on this restart button, and then you'll be directed back into the terminal, which is important for following along here, right? So let's see what mine does in 4 minutes. Okay. SU, okay, so SU, and then a space, and then a dash, and then another space, and then the name of the user. So SU dash Chris. And so we switched over to that user using the SU command. So what is the SU command? The SU command is a way of switching users, of course, but it's a switch users, SU, switch user. And this is, you can switch, I can switch back over to root if I want. So I can switch back over to root. Easier way to do that is just exit out of our current shell, and then to find out who I am or what user I'm logged into, we can do who am I. I don't know the password for root. It was set when this virtual machine was created, so that's why I was having trouble switching over to root. I could switch back over to Chris, and then another way of getting over to root is just the SU and then a dash. If I knew the password for root, I could do that. Or yeah, I can just exit or anything. If I created another user, I could switch over to that user. This is how you switch between users. And again, who am I to determine what user you're logged into currently. All right, so again, we'll go over to Chris and clear the screen. So now that we're switched over to the Chris user, the Chris user has a certain number of capabilities by default, and so let's see, that was our second scenario, right? So that was our third scenario. Okay, so we've created the user Chris with the default shell of the bash shell. Okay, so now we have to create a group, and the group that we're going to create is Docker. And to create a group in Linux is group add, and then the name of the group. So in this case, it's going to be Docker. And you may see that the group Docker already exists. And whoever created this virtual machine, the machine that we're operating on right now, already created the group. So that's cool. That's great. If you wanted to get more information about a given group, we can do get ent, all one word, space group, space Docker. So here's the information about that group. So you'll see this a lot with users and groups, is that they're formatted in a certain way. So obviously, Docker is the name of the group, and then a colon, and then separated by, usually that input is the password. And since this is a group, it doesn't have a password, so this is symbolized by an X. And the 119 is a group ID. Just in general, you know, Linux in terms of organizing all the groups and all the users that are available, there's user IDs and group IDs. And we'll talk about this in a little bit, but the group ID for the group Docker is 119. And there's certain categories of groups. So like 0 to 100 is dedicated for root, for example. All right, so now that we've created the Docker group, or it was already created, so that's cool. We can go ahead and add our user. So we can add ourselves, being that we're logged in as this user, Chris, to the Docker group. So let's do sudo. Sudo is important. We just talked about sudo, and we added this user to the sudo group, as well as what we're going to do right now, which is to add them to the Docker group. And in order to do that, we do user mod, and then a capital G again, and then Docker. Oh, my virtual machine was deleted. Okay, so this is what I was talking about. Our access to our lab environment here is going to expire. So we have to sometimes go in here and refresh. And once we refresh, we can just hit the start button, and boom, we're back into it. So we have to remember those commands before, which are, so let's do this. Let's pump up the. Okay, so hopefully we don't have too many of those interrupts, but we'll have to run those commands again because the machine restarted. We have a new machine now, so now we have to run those same commands. Okay, so again, user add, capital D, S, bin bash, and then user add M Chris. To add the Chris user, pass WD for, this is a good review, right? It's good to review this stuff because we'll be doing this a lot as an administrator or an engineer. So now that we've created a user and the password, and now we can do user mod ag sudo lowercase a g sudo Chris. Okay, now we've added Chris to the user group again. Okay, now we can do sudo user mod. Oops, we gotta switch over su dash and then Chris. And now that we're Chris, we can add ourselves to the Docker group. Or we gotta create the Docker group. Group add Docker add already exists. Get, okay, we already did that. So it already exists. Sudo user mod ag Docker user. This is fun, right? This is like, I feel like I'm in a movie, typing all these passwords and doing really specific commands. Okay, I added myself, and I'm kind of assuming Chris here. So I added Chris to the Docker group, and if you notice, I used another environment variable. Environment variables are used lots of places. an environment variable for getting your user is just echo user. It's pretty cool. So no matter what user you are, you can use the user environment variable, and it tells you. If I didn't know already, I know, obviously I'm the Chris user, but let's move on. So now to see what groups Chris is associated with, we can do groups Chris, and we could do sudo bang bang to run that previous command as sudo. And now we see Chris is a part of the Chris group. When you create a user, you automatically create a group as well. That group is the same as the user, so in this case Chris, and you get added to that group automatically. And then we added Chris to the sudo group, and we added Chris to the Docker group. Okay, we have everything all set. We can also cat out the Etsy group and see all the groups that are available on our system. And at the bottom, you notice we have the Chris group and the Docker group, Ubuntu group, systemd core dump group, lots of different groups in different categories of groups so that we can determine what these groups are for. Okay, that was a lot. Let's take a pause for a second and look at the chat, see if there's any questions. Okay, no questions. Okay, so just to recap, we have, okay, let's switch over to slides. Okay, we've found out the information about the current distro and other systems, such as other system info, I should say, in terms of CPU and RAM. We've taken a look at the syslog command or syslog file and learned different commands to filter through the syslog and to grep the syslog or to search through the syslog. We've taken a look at how to create a new user. We've created a new user named Chris, or whatever user you named your user. I hope you're able to follow along there. And then we created a Docker group, and we added Chris to that Docker group. We also added Chris to the sudo group. Oh my goodness, we were going so fast. I hope you were able to keep up. Okay, whew. Let's move on to the second section, shall we? All right. Everyone able to follow along so far? Everyone good? Give me a thumbs up. Give me a holler in the chat if you're listening and you're with me so far. All right, alrighty then. So let's talk about commands. We've already run quite a few commands, and so there's not a lot to review here, but we'll get into the commands that we haven't run so far. How about that? And then we'll talk about yeah, because there's a lot of different commands that we can run. As you can see, we have file operation commands. We have the file permission commands. We have directory commands. We have bash variables. We talked about environment variables. That's a really important one. And then let's talk about packages too. So we're going to be using the apt package, or apt. And so if you see in the upper right-hand corner here of my slide, we have the apt package, and being able to go through that and update our packages as well as install new packages. I sometimes use packages, sometimes use software. They're interchangeable, so they could mean the same thing. So I'm just installing a program or a piece of software on my machine. A lot of times we use a package manager because it's easier to install because we don't have to figure out, like I said before, certain pieces of software, they have certain binaries or certain files that go in certain directories. If we don't know where those files go, or maybe we don't really care to know where those files go and what directories and subdirectories they go into, we can use a package manager to make that a lot easier, because the package manager knows everything, where everything goes and how to install things, and just makes the whole process a lot easier. So we don't have to take a lot of these manual interventions and these manual steps to install the software that we need. So this is very important. Package managers are an essential piece of the Linux operating system, and being able to use a package manager to your benefit. I do have a cheat sheet if you're interested. So if we go over to my cheat sheet, you can go ahead and download that cheat sheet. So let's see. If we go over to GitHub and to my account, and we go to Linux-Docker. So I'll put this link in the chat, and we can go over and check out that cheat sheet. So github.com/chadmcroll/Linux-Docker. Okay, so this is the repository, the GitHub repository that I created for this particular workshop. And so if we go in here and we go to the Linux cheat sheet, there we go. So here are all the commands that are very important for, some of the ones that we've already run, of course, but also very important for operating a Linux operating system and operating within a Linux operating system, I should say. So this is very cool for just easy reference. What was that? How do I list the directory again? Or how do I change directory? Or how do I, input to output? And how do I do certain things like that? How do I navigate and create new files and all that good stuff? So all that's in here. So check out that cheat sheet at that link in the chat. All right, so let's switch back over to the slides. And if you want to use the cheat sheet as we go here, that's cool. And but I'll be walking through it with you, so no worries. I think the cheat sheet is more for like after we're done here, after today. If you want to keep that as a reference, you can always, maybe use it or maybe add to it or whatever you feel is fit for what you do every day. So let's go through workshop number 2. So let's go through learn by doing and go through some more examples and learn as we go here together. So number 1, first scenario that we'll be going in this kind of section on commands and packages, we'll be going through changing our prompt. So let's say we didn't want to, let's say we didn't want to use the prompt that it came with, that the bash shell came with. Let's say we wanted to change our prompt to something else. So let's go ahead and change the prompt to my new prompt and then a $sign. A lot of times a $sign indicates the end of a prompt. So we know that everything that we're typing is after the $sign. The scenario number two we're going to go through together is creating a directory. Let's create a directory named dir1, dir, sometimes we call it dir, in the Chris home folder. So in the home folder that was created for Chris, we'll create a directory. That's cool. And then we'll copy that directory. We'll learn about the cp command to copy files and directories. And then we'll create a file within that directory named file1.txt, and then copy that file to file2.txt and rename that file as well. So we'll get to use 3 different commands there to do that. And then finally, we'll go through together installing software. So using the apt package manager like we just talked about, and updating our package repository and how it updates, and talking about installing the Docker engine, which we'll be using pretty soon in the Docker section of this workshop. So cool. Let's go ahead and switch over to that and get started. So hopefully your session hasn't expired yet, so we can continue and do all these things as the Chris user. So change the prompt, and then I might have to use this as a reference to switch back and forth, but it's cool. All right, so number 1 is changing the prompt. How do we change the prompt? As you see here, the prompt currently is this bit right here. So what's before my cursor? So in this case, it's Chris @Ubuntu, which is the name of the machine, which you can get by typing in hostname, by the way, and colon lol tilde is what we call it, the squiggly bracket, or the squiggly brace, or no, it's a tilde, and then a $sign. And then we do our commands after that. So that's called a prompt. If we wanted to change our prompt, we use this thing called PS1. We set our PS1 environment variable. Our PS1 is, so we can echo that out, right? So we can do PS1. Yeah, this is the information that's So this is a series of commands. Don't get too confused about this. This is just how the information that you see in the prompt is obtained. So this is not a static value, meaning that you won't necessarily see Chris at Ubuntu. You'll see how we get the information that essentially translates to Chris at Ubuntu. So that's the PS1 environment variable. We're going to change that environment variable, and we do that by just typing in PS1 capital. Linux is case sensitive, so you have to remember that. Very important that we use capitals and lower cases where necessary. And then we do my new prompt, and then a space, $, and then another space, and then an end quotes. So we're going to put all that in quotes, and then boom, we've changed our prompt. We have a new prompt, so we can echo out that PS1, and now we have that exactly as we typed, that static value. If you want this to remain persistent, so when I exit out of here and then I change back to the Chris user, it changes back to this, and it does that because of our bash profile. Our bash profile is essentially a script that runs every time we log in as a new user, and we can locate this bash profile, or sometimes it's called a bash RC, by just either catting it out. So we can do, and it's located in our home directory. And in order to find it, we can do ls. But as you notice, it's a hidden file because it starts with a dot. So hidden files in Linux always start with a dot, and then it's the name of the file. And just by typing ls, you won't be able to see it because it's hidden. So if you maybe want to create a hidden file, well, actually, I'm getting ahead of myself. So let's talk about creating files in a second. But in here, we see the bash RC. So we can cat out the .bash RC. And we'll see all this information. And we can do less again to see it line by line or frame by frame. All this information runs when we start up our bash shell. So we see all of these commands are running. The ones that have a hashtag before it, or a pound sign, are commented out, so those don't run. But all the ones that don't have a pound sign, they run every time we start up the bash shell. So that's how that gets reset every time the PS1 value for an environment variable gets reset every time we establish a new shell. In this case, when we switch over from the root user to the Chris user. So all of these things are happen. Okay, so if we wanted to change that, so let's hit the up arrow until we get to our command. Let's do clear so we can get back up. So get back up to the top so you can see better. And let's go ahead and take this command that we ran, PS1, resetting the PS1 environment variable. Let's copy that, just Command C or Control C. And let's go ahead and use echo. So echo this, and we're going to echo that, and we're going to use the caret, the forward caret, or the right caret. So it indicates that we're kind of stuffing this into the file bash RC. So this is appending, being that I indicated 2 carets here. If I wanted to overwrite the entire file, I could do a single forward caret or forward arrow there, but I'm going to do 2 because I want to append to the end of it. So now when I cat this out, and we can just do cat. See, it's at the end now. So PS1 equals my new prompt, then a $. So that's going to be our new prompt. So if we do source, let's clear again, source our bash RC, that means loaded into our current session. Oh shoot, we had the syntax a little bit wrong. So let's go into our file. I'm getting a little ahead of myself here in terms of the complexities that we're getting into here. But let's go into the file with our favorite text editor. And let's do this. Let's do, it took out our quotes here. So we're just going to put our quotes back. And then we're going to save and quit. We'll get into using Vim a little bit later. Don't worry about that right this second, but we're just doing that so that we can source our bash RC again. And once we source our bash RC, we can get our new prompt. And then when we exit out and we go back to root and then we change back to the Chris user, we can always see that new prompt, which is pretty cool. So this is how you set that prompt permanently. So this is always a prompt that we'll be using as long as we have access to this machine. So which is very cool. All right, so that was our first. So if we switch back to our slides, that was our first scenario that we went through together. Let's go to the second one. So creating a directory. All right, so let's create a directory. So if we type the cd command, we're just going to go back to Chris's home directory, which is in the home directory. We already talked about the home directory, right? That's where everyone's files go and everyone's individual files. So everyone can have different files in their home directory. All right, so let's create a directory. So to create a directory, we can do mk dir or dir. I call that dir a lot of times. I think that's pretty common, but maybe not. And then make dir and then space and then directory one, dir1. And then I can also, if that directory is already created, let's say I already have a dir1 directory, we can do dir, or actually we can do mk dir -p. So this ignores the fact that directory is already there. It just creates a directory right over the previous one. So that's a good one to remember if you want to overwrite an existing directory. mk dir -p. Okay, so we've created a directory. Let's move the directory, right? Because that was our second one. So create a directory, and then we want to copy the directory. Okay, so let's copy that directory, and we can copy something by using the cp command. But because it's a directory, we have to use the -r to signify a directory. So we'll do cp -r and then dir1, which is the directory that we're going to copy, and then the directory that we want to copy it to. So we want to do dir2. So if we list the contents of our directory, now we have dir1 and dir2. It's so dear to my heart. It's awesome. So now that we've created a copy, we can delete dir2. So let's delete it. But because it's a directory, we have to do rm-r. We can't do rm dir2 because it's a directory. So we can't remove it without the -r. Very cool. All right, so we've deleted directory 2. So let's go ahead and create some files, right? The next one was creating a file named file1.txt inside of the directory. Guess what? We don't even have to change directory into directory 1 to create files in there. We can just create them from here. We can use what's called a relative path. So the relative path is this right here, our present working directory. That's relative to the path that we're going to specify in our command. If we wanted to use an explicit path, we could type this out every time. But because we want to use relative, we want to reference the relative path or relative to where we are in the file system. So to create a file, we use the command touch. Okay, so touch dir1 is the directory that we want to create a file in, and then we could do file1.txt. Cool. So touch is very common for creating files, and just an easy way to create a file, just an empty file, and not have to insert any text into it. Touch is an incredible resource. So we can do, CP. We can copy a file. Let's see. Copy file1.txt, and then maybe you want to dir1 file2.txt. We want to copy that. So if we do ls dir1, we'll see we have file1 and file2 in directory 1. We didn't even change into that directory. Crazy, right? Okay, so move dir1 file2.txt, and then we can move that, which means to copy, right? So if we do the mv command, it means to move, which essentially is renaming it and moving it to another directory, or in this case, we'll keep it in the same directory and we'll just name it file1.txt. So if I do my ls command again, I have file 1 and file 3 because we moved file 2 and we called it file 3. Cool. Everyone with me so far? Thumbs up. Okay, looks good. All right, so we've done the file stuff. We know how to create files, copy files, and move files or rename them. Let's go ahead and get into the apt package manager. Okay, so apt is the package manager for Ubuntu, as we've already discussed. And besides being a package manager, like I said, package manager is just makes it easy to install software because the package manager knows where all the files go and which one should be executable and how to reference that to your current path. If we echo out the path, these are all the directories which contain executable files. So we can, these are in our current path. So anything that we type or any command that we type that is also within these directories is an executable. So that's how we can utilize some of the commands that we've been running, such as user add and passwd and ls and mv. All those are in our path, so we can use them in our current path. It's pretty cool. All right, so how does this package manager, this magical package manager, know where to retrieve my software? Okay, so this is in a sources directory. So if we cat out our sources directory, which is in the etc directory, inside the app directory, and then is sources.list. So this is a list of all of our sources. So this is where it gets all the software. So when we do a sudo apt update, which is how we update and retrieve information using from those sources, bring it down to our local machine. That's what that's doing. That's where the sources are for those updates. That's where the sources are for those updates. And also, there's another directory in the apt directory, which is the sources.list.d right here. So if we copy that and we cat that out, and we have to use the relative path, there's nothing in there because we don't have any packages added to it currently, but that's also a source for different packages. And every time we run the apt command, it looks for those sources in that file, and it makes sure that I'm sorry. If we list this out and then this is a directory, so we weren't able to no such file. Yeah, so there's nothing in there. Okay, yeah, I did that right. Sorry. I thought I hadn't gone deep enough in the file system there for a second. Okay. Yeah, so apt update we already saw. And again, this requires sudo permission, so it's going to tell me you can't update the packages unless you're sudo, or assuming root, that is. And so let's install some packages. And sometimes the packages that we install are not a part of those sources that we looked at. So in here, yeah, it's not in this sources.list directory. So what do? Sometimes we have to add to that, and we'll sometimes we don't, but sometimes we do, and we'll run into this when trying to install Docker. So let's go ahead and let's do one that doesn't require us to add to that sources list first. So let's do sudo apt, and again, apt is our package manager, so we're installing from the package manager, and a -y just indicates that any prompts that may come up to ask us whether we really want to install the software or not can be, we can say yes to those. So a -y just stands for yes, and then we'll do CA certificates, which is a common prerequisite to installing Docker. So CA certificates, so certificate authority. And so we can utilize certain things like OpenSSL to create certificates. That's beyond the scope of this course, but maybe something you'll get into in the Kubernetes section in future workshops. Okay, so let's do another one. Sudo apt install curl. Curl is a very important tool for. See, we didn't do the -y there, so we had a prompt. Do you want to continue? So curl is really good for being able to request information from websites, and it goes out and says, either you can download a file or you can check if that website is available. Curl is a good tool for seeing where your traffic is going and if you're getting responses from that traffic. So let's do another one. Sudo apt install GNU PG, which is GNU is for GNU, but also is for the GPG keys, I believe. I think, yeah, GNU Privacy Guard. So we're talking about getting the necessary files that allow us to work with GPG keys, which are just making sure that the software that you're pulling down is valid and it's coming from a trusted source. So it's very important. Okay, so let's do one more. So let's do sudo apt install and let's do a -y this time, lsb release. I think we already have this installed. Yep, okay, we already have this installed. So that's not gonna do anything there. Okay, so those are all the packages that we need to install as a prerequisite to installing Docker, but also they don't require us to add to that sources list because they're already a part of that sources. It was already part of that default list that we looked at the beginning. So how do we? So Docker is one of those ones that's not added to the list. Well, the version of Docker that we want to install, that is, I mean, if we do sudo apt install, let's see, let's do apt install. Let's see, let's just do Docker. Oh, it's already installed. Okay, well, let's go through the. I think it's good to go through the process anyway. I should have known that Docker was installed already, but we can reinstall it and just go through the process of adding to that sources list, which is what I want to cover when going through these scenarios with you. All right, so again, I talked a little bit about GPG keys. To make this process a little bit easier, because we're going to be entering a few commands, if we go back to where we got the cheat sheet, right? So this is a directory that that we're going to use for this entire workshop. So have this up. Again, it's just if we could post that in the chat again, that would be great, and so we can reference this as we go along here. This is what I'm following just to keep on task here and just make sure I'm going through everything appropriately and going through everything step by step. I don't get ahead of myself and stuff like that. So if we scroll down to challenge 2, we'll notice that we have a couple commands here, and we can just copy and paste these as opposed to typing them all out, which will save us a whole lot of time. So let's go ahead and do that. So let's copy this one, which is, again, under challenge 2. I called these challenges in this README document, but it's fine. So let's go through challenge 2. Yeah, there's if you do in your browser, if you just do a #challenge-2, you'll be directed right down to it. So that's an easy way to get to it as well. And if you scroll down to this part right here, we just ran all this, right? Sudo apt install ch certificates, apt install curl, and this backslash here is just a way of doing a line continuation. So this is just running. This could be all on one line. It'd be the same thing, but a lot of times to make it a little bit more human readable, we insert this backslash here to continue our command on the next line, and then we keep doing it for subsequent lines until we get to the last line, of course. Okay, so if you're with me, we can go ahead and just copy this command here, these two commands, I should say. So we're gonna create a directory. Remember the make dir? We just did that. That's pretty cool. All right, so we're gonna go over here and paste that into our terminal. And so what it did is created a directory in the etc directory. We had to use sudo because we're not allowed as a regular user to access the etc directory. And then we use curl. Remember we talked about curl? Curl is going to download this GPG key to that directory. And that's how we kind of authenticate or get the keys to be able to download our software, which is the Docker software in this case. And then if you scroll down to go past all these comments, and if you go down to the echo command, right? So we've done the echo command before. Echo is a good thing. Is a good command to use for putting a string into a file. In this case, we're going to put the this string right here, the one surrounded by quotes. We're going to put that in a file in etc apt sources.list.d. Hey, we just took a look at that sources.list.d just a moment ago, so we're very familiar with it. Very cool. We can do that, and everything will be hunky-dory. All right, so let's do that. And now, if we list the contents of that directory, so I'll search for that that command that we ran, which is ls, and then I will do, if you remember, Command R again to list out the sources.list.d. There it is, docker.list. If we cat that out, let's cat that out and see what's in there. And we should know already, maybe you've guessed it, it's going to be whatever was in quotes over there. So that's pretty cool, right? So yeah, it's all this in quotes. All right, so now we get to the good stuff. Even though we've added this to our sources list, we still need to update our packages because we haven't updated our package locally, and we can prove that by doing apt search. Apt search just allows you to search your existing packages that you have down locally. So let's go back over to our terminal and let's clear the screen, and we can run apt search docker-ce. That's Docker Community Edition is what that stands for. And yeah, it's not there. We have to update our packages, and we've already done that before. We can do it again. Apt update. And oh, we forgot sudo, so we can do sudo and then bang bang or exclamation exclamation. Just runs the previous command with sudo attached to it. And we can pull down those packages, so we can have those packages locally, and therefore allowing us to install Docker-ce. So now let's do the search command again. Oops. Let's do the search command again. Apt search. There it is. Now it's showing up in our local sources.list for our local packages, for our packages that we pulled down locally. So that's very important. So let's go ahead and clear the screen. And now that we have those packages locally, we can go ahead and install them. So let's go back over to our little cheat sheet here. And I think this is the last really long command that you might want to copy and paste. You can also type this out, but it's up to you. I'm just doing this for the sake of time because we're already kind of hour or so into it. And yeah, I just want to speed it up a little bit. So let's go ahead and install those packages. So not only are we going to install docker-ce, but we're also going to install the Docker CLI, which allows us to interact with Docker from the CLI or our terminal or our command line. All mean the same thing. And then we're also going to install containerd, which is a container runtime. And then we'll talk about container runtimes when we get to the Docker section. And then Docker Compose also, because Docker Compose will be important later on. We'll get to that for running multiple containers at once. So that's pretty cool. All right, so now we're installing Docker. We're waiting for it to progress 65% according to my computer. And so let's take a look at the chat real quick. After knowing about SE OS release, I think it is better to prefer cat OS release over man OS. Is it so? Okay, so the difference between cat OS release and man LSB release is if you're catting something, you're just displaying the contents of that file. So that's what cat is. It's just displaying the output of that file, displaying what's in that file. You want to find out what the contents of a file is? Go ahead and cat it out. That's a common term. The man OS, the man LSB release, or maybe you meant OS release, running man just gives you the manual pages. That is the metadata, if you will, about the command itself. So what does the command do? What is it? What are the flags associated with it? How can I output certain information from that command to, or how can I run my command in a certain way that will get me a different output than if I did not include those flags? So that's the difference between, catting out the OS release over using the man pages or the manual. I don't want to be sexist here, so I'll just keep referring to it as manual. We just use the short-term manual. All right, so, and perhaps if you meant to use the LSB release, catting, LSB release command by itself or with the -a, I think, yes, you're right. OS release will give you more information. I think that etc OS release is common throughout more Linux distributions, like the LSB_release. That won't always work with other distributions of Linux. So take a look at that for future use. So OS release, you can count on that. You can count on that being in a lot of other distributions. Okay, I think my screen froze or something, so I'm gonna hit the Control-C. Oh, actually, I just have to answer that prompt. So it just wanted to, it wanted to ask me if I wanted to keep my current version of the config.toml. Okay, now that that's done, I can go ahead and run Docker. I can run Docker to get all the commands I can run with Docker, or I can do Docker version, do that too. So hopefully we have the latest version, being that we've pulled that down. So 20.10.17 should be the current version. And we can also do Docker run hello world. And this will just run a quick little container just to tell us if Docker is configured correctly, which it is. It says this message shows you that our installation appears to be working correctly. Awesome. All right, we're good to go. All right, so let's flip over to our slides. Sorry if I'm going a little quicker here. I realize that I'm kind of elaborating, taking a little bit too much time. We have completed all 4 of these scenarios, so that's great. Let's move on to files, permissions, and redirects. We already kind of did redirects, right? So that's pretty familiar, and we should be able to breeze through that. But also let's talk about Vim and using a text editor. My favorite text editor is Vim, and hopefully you've been introduced to it at some point or another, but it's a common text editor that comes out of the box with Linux. This means that no matter what Linux box you're accessing, you can always depend on Vim being there to use as a text editor. So that's very important. All right, so let's skip over to that. And yeah, I think the mainly, I mean, we'll get into using this. On the right-hand side of the screen, you'll see the commands that are used inside of Vim, but it doesn't make much sense unless we kind of get to using it. So let's learn by doing. And oh, sorry, file, apologies. I got ahead of myself a little bit again, and let's come back to using Vim, and let's talk about permissions really quick. So man, I really let's talk about permissions in a Linux file system. And user and group is supposed to be moved over a little bit. I wonder if I can change that. Ooh. This is what happens when you're live, right? You have no, this is really live and raw, as they say. All right, so move these over. I just want this to be correct. All right. I want to move these over to here. Okay, it doesn't have to look perfect, but you get the idea. All right, let's continue. So let's talk about the permissions a little bit. So when you're looking at a file system, and let's say you run the ls-al command from your terminal, this is going to output all the directories, files, and symlinks, or links to other directories, inside of the directory that you run this ls command from. So in this case, I'm in the root directory, and I'm in the home directory, and I'm listing out all the contents of my files. And I see, like we saw before, the bash rc, which is our bash profile, and gets run every time we start up a new command or start up a new shell. And we know these files and directories, what permissions they have, by looking at those two columns in which these two arrows are pointing to. The first column is the user column. So what users, what is the owner user, I should say? What's the owner of this particular directory or file? And then the second column there is the group. So in this case, all of the directories and files in this, I'm logged in as root in this particular example. But if we go over to, let's do the same thing in our Chris directory, and we'll see Chris is an owner for a lot of these files, and the Chris group is the owner for a lot of these files as well. So this is the information about who has access to these files, whether it's the user or the group. So it's pretty important, right? So so that's how you know that. And then you may see these over on the left-hand side. You may see these, LRWX. What does that mean? Well, the first letter in that series of text is the indication whether it's a file or directory. Oh man, I really messed this up. So sorry about this. I need to switch these. D stands for directory, of course. And then the slash there is a file. So sorry. All right. Really messed that slide up. All right, so the D is for directory, the dash is for a file, and the L is for a link or a symbolic link. That just means it's a reference to another directory in somewhere else in the file system. And moving on to the second one is a read indication. So that indicates that this file or directory is for reading. And who does that? So let's fast forward a little bit. Who does that read? What does that read mean? It means like the owner can read it, right? So the first group of 3, so you see RWX, 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 right? That first group of RWX is for the owner. That's the owner group, group of permissions. So the owner in this case can read, write, and execute. So that means that they can read, write, so they can read this file, they can write to this file, they can overwrite it if they want, and then they can also execute this file. So they can, they can run it if they want to. It's executable. And then the second grouping, RWX, is for the group. So the group has a certain set of permissions to read, write, and execute on that same directory or file. And then the third is the other. So everyone else other than the group and the owner, that's their permissions. So as you see, a lot of them are just R, meaning just you can only read it, you can't write to it or execute. So those dashes indicate that permission has been taken away. So if that doesn't make sense, please let me know. But essentially what you're looking at here is the, depending on what file you're looking at, this is the permission for each group of people or group or users or groups. So I hope that makes sense. Please take a screenshot if that doesn't make sense. And then feel free to ask questions in the chat if you are still confused. Okay, so moving on to workshop number 3. I'm starting to speed up a little bit because I realize that I'm kind of behind time. I want to give appropriate amount of time to the Docker section. So first scenario that we'll be going through together is piping. So we've already done this, but we'll view the contents of the syslog and filter based on the word Ubuntu, and then we'll pipe to less. The second scenario is creating a file with Vim, and we'll name that file script.sh. .sh file usually indicates that it's a script. And then in the Chris home folder, we'll type the word bash inside of the file to indicate that it's a bash script. We won't get into scripting in this particular scenario, but that is an important thing that I encourage you to take a look at later on. And then we'll go through the third scenario, which is using the chmod command, or changing the ownership of the file. So we can modify we can modify the RWX part of what we just looked at in the previous slide. So that's pretty important. All right, so and then we'll go through the fourth scenario, which is inserting paste in text from pasting in text from the web. So pasting in something into script.sh and see how we use the set paste parameter inside of Vim to take away the formatting. This is used in a lot of, I use it on a day-to-day basis when I'm copying and pasting YAML, but it's used to make sure that the formatting gets taken out so that you're not having extra lines being put in. If you know anything about YAML, you'll notice that spaces are very important. And so we'll take a look at that. Let's go ahead and switch over to our terminal. And we're doing good on not still having access to our terminal using the Chris user, so that's cool. So let's cat out, again, the var log syslog. Oops. We used an explicit, so every time you do the / here, so var log, I started with a /, so that means this is an explicit, I'm explicitly stating, again, I don't know how to type and talk at the same time, but I'm explicitly stating that we're starting at the root directory, that's the /, and then we're going into the var directory, log syslog. And so this is not a relative path, this is an explicit path. All right, so what we're doing here is a little bit more advanced, right? Because we're piping twice. Ooh, crazy. So we're grepping to, we're grepping, right? We talked about grep before. We're searching the syslog file for Ubuntu, but not only that, we're piping that to less so that we can view this frame by frame. So let's do that. And oh shoot, there's nothing in here. So let's see, what did we do wrong? Permission denied, that's why. Okay, so let's do sudo cat. We can do sudo bang bang. And there you go. There's the less version, you know, only viewing a certain amount inside the window at a time. And I just hit Q to quit out of there. So that's piping something twice. And so I can not only search, but also use less, which is very useful for searching through long log files like the syslog. All right, so let's go into creating a file. So vim script.sh. So remember we did touch. I could do touch script.sh, but I could also create the file and be directed inside the file so that I can start editing my file all at the same time. So I can do vim script.sh, and I get thrown into a different screen. This is my text editor, which is maybe confusing at first, but it'll be really fun to explore this a little bit. So First off, navigating throughout this file, because it's blank, we can't really navigate through anything, but let's say we wanted to type something. In order to type something, we can't just start typing. We have to hit the I key on our keyboard to go into insert mode. Insert mode allows you to insert text. So we can start typing away, blah, 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 blah. And we can start typing text as fast as we want to and filling out the contents of this file. All right, so now that we've been in insert mode and we've entered all the text that we want to add here, we can go ahead and hit the escape key to exit out of insert mode. All right, so now that we've exited out of insert mode, we can go to the top of the file. Let's go back to the top of the file, and there's a key combination that you can use to do that. And the key combination is GG. So if you hit G twice on your keyboard, you'll be automatically directed to the top of the file, which is pretty cool. And then to go back to the bottom of the file, we can do Shift G. Shift G allows you to, that key combination allows you to go to the bottom of the file. And we're doing all these in command mode, by the way. So we were in insert mode before. The mode that we're in, Vim has many different modes. We're in command mode. Insert mode, just remember, insert mode is to insert text. Command mode is to, do these various commands that we're running, these shortcuts to navigate the file. Okay, and then a couple other important ones are, let's say I wanted to go to the beginning, or let's say I want to go to the end of the file. So I can do Shift and then a $. So Shift $, or Shift 4, to go to the end of the file, to end of the line, excuse me. Go to the end of a line by doing the key combination Shift $, and then Shift up caret, or what do you call that? 6 on the keyboard for me in the US keyboard, sorry. So the up arrow is what you're looking for on your keyboard, Shift, and then that key to go to the beginning of the line. Okay, so let's do something fancy here. So let's go into visual mode, okay? So hit the V on your keyboard. You're now entering visual mode. We talked about insert mode, we talked about command mode. Now let's go into visual mode. Visual mode allows you to select all the text that you want to select. And maybe you want to delete that text, so we can hit the D key to delete it. And then that takes us out of visual mode. We don't see the visual at the bottom of our screen anymore, right? So we can go back into visual mode, and maybe we want to select multiple lines and then delete those lines. Or let's see, let's go into visual mode, and then let's select a bunch of text, and then we can do something to copy, and but it's called yank, Y-A-N-K, yank. That's what we call copy sometimes. So it's the Y key on the keyboard. That's how you remember that. Y to copy. See, it says 4 lines yanked at the bottom left of the screen. And then we can also do the P. Press P on your keyboard, and that pastes. So that'll paste those lines that you copied into the terminal. So into the file, rather. So let's go through that again. So, oh, we got 4 minutes. Okay, so let's, it's not really, it's not gonna explode or anything. It's just, I don't wanna have to recreate the Chris user and all that. So anyways, let's go ahead and go through that again one more time. So GG to the top, Shift G to the bottom, Shift $, to the end, Shift caret, or Shift 6 to go to the beginning, V to go to visual mode. Use your arrows to select multiple characters, and then you can do D to delete, and then you can do visual again to go back to visual mode, and then you can do Y for yank, and then you can do P for paste. And then to get out of this file, you just hit the escape key, or let's see, we're already in command mode, so we don't need to press the escape key. If you are in visual mode or insert mode, you would hit the escape key to get out of visual mode. See, I just typed V and then escape. I'm now back to command mode. I escape, now back to command mode. And now I can simply type in colon and then W for write, Q for quit, and that closes the file, gets us back to our prompt, which is pretty cool. So again, colon WQ, or if you don't have anything to save in that file, maybe you want to, maybe you want to quit without saving, you can do Q and then an exclamation point to make sure that you do not save anything. Or if there's nothing to save, you can just do colon Q. Or if there's nothing that's been changed in the file. Okay, cool. That's Vim. Very exciting. All right, so what's the other one here? So Chmod. So change the ownership of this file. Oh, we didn't create the file. So let's, yes, we did, script.sh. So this is our file, and I forgot to enter bash. We were supposed to enter keyword bash. So I'll delete all this, and I'll go back into insert mode, do bash. And a lot of times in the beginning of a bash script, we do pound exclamation point bin bash, and we call this a shebang. That's a joke for another time maybe, but yeah, shebang is what that's called, and that's usually the beginning of a bash script. All right, so let's change the permissions on this file, shall we? So let's ls-al. So right now, we've created this script.sh file. Here it is on our screen. And as we know from looking at the permissions from before, so in that, so let's go back to this. And so that first block is the owner group other. So let's owner group other. So owner, being Chris, has read write to this file. The group, which is also Chris, is read write also, but everyone else only has read, because all the other two are dashes. So that means they do not have any access. Let's go ahead and change this, and we can easily do this by doing a chmod. And let me clear the screen first. So clear the screen, ls. Let's do a chmod. So change modification, or however you want to, view that. We're changing or modifying a file, and we're going to do, let's say we want to do other. So the other, remember, just has access to read. Everyone besides the owner and the group, everyone else on the system only has read. So let's change that to, and we signify that by doing a plus sign and then W. So the other category of our file permissions, we're going to give that write access in addition to read, and we're going to do that for the file script.sh. And then if we do ls-al again, and we'll see, we changed it. Now it's RW in that other grouping of our file permissions. That's pretty cool, right? All right, so let's make this executable, which is another thing we can change. So again, read write, but no executable. Let's do executable for our current user. So chmod, and we can do +x. We don't have to signify. We could do, I guess we could do U here for the user. But since we're effectively performing this command as the current user, this is going to be implied that it's going to indicate our current user. And you'll see what I'm talking about in a second. So chmod +x Chris, or +x, and then script.sh. All right, ls-al, boom. Oh, that's for everyone. So that's a command that you can run to give executable permissions for everyone. And there goes my machine. Okay, so we can just hit restart over here, no problems. Get a new machine. I'm sure this has happened to you a couple times as well. And we'll just keep going here. We're not gonna, let's not worry about creating a new user and all that, just for the sake of time. But we can see ls.al, and then we can do, let's just do touch script.sh, and then again, we'll do chmod plus x for everyone. So everyone has executable permissions, and then script.sh. So ls.al, there we go, script.sh, and it changed color. How cool is that? That's because the bash script, the bash shell is so cool. That is awesome. So we have gotten through most of this. So let's do paste in the text from the web. Okay, so let's use set paste, shall we? So let's just go over here to that cheat sheet that we're working on. So let's say we wanted to insert all these comments here. You can really copy and paste anything you want to. And then let's open our file again, script.sh, and we'll go into insert mode. And before we go into insert mode, actually, we'll do a colon and then set paste. And then that will take out any formatting that's associated with this information. So then it'll be appropriately spaced and appropriate, just how it looked in, so a good example again is if I go to Kubernetes.io docs, and then I go to pods. And so see, I have a simple example of a pod here. This has a lot of spaces in it. See, I don't want all that. I do want all of that spacing to come through, but I don't want it to be kind of auto formatted, so it adds extra spacing in there. So that's the use case there, where I would do a set paste, and then I would do a paste. I would do a Command V for paste, because I've copied it to my clipboard. So so yeah, that's basically it for taking out the formatting when you're copying and pasting from the web. So that's kind of useful many times for me. You can also do set unpaste to set, what is it? Set, let's see, unset paste. What is it? I forgot. I actually wrote it down here. So let's do set paste. Maybe I didn't. This is the cheat sheet. Set no paste. Aha. That's why you write notes. Set no paste. Set no paste. There we go. And so this will add all the formatting in the event that you do want formatting. All right, I think the no paste is there by default, but here we'll do, we'll quit and not save our changes. So we'll do a :Q exclamation point, or a bang, as we say. And that's about wraps it up. So let's workshop number 3, done and dusted. All right. What's next here? Okay, we'll talk about services next. Let's talk about services. So, all right. So all right. Let's talk about services. Services in Linux are, again, a grouping of files. Again, it's very important to know that that's all that it is a grouping of files. And services are, when you start up a program, a service starts in the background. Some of the services are in the background, some not. For example, the bash shell is a service that's in the foreground, being that you're using it as your current user. But yeah, services are very, very common in a Linux system, and the grand service, or the services that control all other services, is called systemd. And you'll see I grepped for systemd here in the output in this particular screenshot. But systemd is very important to remember, and very important to know in terms of Linux system services. Systemd is the, I should say, the Linux service that controls them all. All right, so let's go out, and then, sorry, I want to talk about Git as well. We'll go through some Git commands: git add, git reset, git diff. I also included a Git cheat sheet here if you want to reference that after we're done here. So git Chi is in that same repository, and we can go. You can reference all those commands that we're about to go through together right now. Okay, so you don't necessarily have to be the Chris user for this. So because my system restarted, I got a fresh new VM. I'm not going to go through that just for the sake of time, but hopefully you're still with me here. And just checking the chat here, and I don't see any questions, so let's move forward. Okay, so Linux system services. So in order to, actually, let's go through the scenarios here. So the scenarios that we'll go through together are viewing the services running on the Linux system for all users, okay? So there's a command that we can run to view all of our system services, so that's pretty cool. And also, we can narrow that down to just looking at the system services for the Chris user. And shoot, I guess we have to have the Chris user. Okay, so that's fine. So Nginx, let's go through installing Nginx. We can use the apt package manager for that, and then verify that services are listed and enabled for Nginx. And then we'll go through logs, and we'll stop and start the Nginx service. We'll check the logs for the Nginx service using journalctl, which is a common command for filtering through logs. And then we'll look at some commands in Git and create our Git repository, which is pretty cool. All right, so let's go jump over to our thing, and then let's quickly go through. So in order to, so let's just do a user add. I don't know how to get around this, so let's have to go through this again. Chris, and then pass wd Chris, and then set password. Password updated, and then we want to do the user mod ag, and then sudo Chris, and then sd Chris. Oops, we didn't change the, so we can just do bash. There we go. Okay. So a lot of times, if you don't see the bash shell, I didn't take the time to change the default shell. A lot of times you can just type in bash, and then it'll get you the bash shell, as opposed to going through changing the default. But it's good that we know both ways. All right, so to check out the Linux system services, let's do ps.aux. AUX, again, if we do man ps, we can find out what those things mean. But for the sake of time, let's just check out all of the Linux system services. So these are all the services that are currently running on the system. Some in the background, some in the foreground. These are all the Linux system services. So that's pretty, that's a lot of system services. I mean, that's a lot taking up useful resources for your machine. Some of them are smaller than others, but those are all the Linux system services. So if I wanted to see just the ones that are related to my particular user, I could do, I could do grep. Grep we've used before, and oh my goodness, okay. ps.aux. And we can grep out the ones that are just pertinent to our user. So that's, like I said, the bash one is one that the user uses. These commands also count as system services. Every time I run a command, it gets loaded into the foreground and starts up as a service. So it's pretty cool. Let's go through listing the services that are daemons. So I alluded to this earlier, but daemons are, systemd is a daemon. Daemons that are running in the background that allow our system to run, but in a lot of cases are kind of supporting our environment that we're running in right now. So, so whether it's supporting the bash environment or supporting the programs that we're running, like Docker. And so daemons is what they're called. So a lot of times you'll hear Docker daemon or the Linux daemon, systemd daemon. A lot of times that's what's meant by that. So if we do sudo systemctl, and then we do list units, which is another way of listing the system services, and then we'll do a -d, and then we'll do service. And because it's sudo, we have to type in the type in our password to assume those privileges. And then here are all of our daemons. So we have the accounts daemon, we have the console daemon, we have the cron daemon, we have the Docker daemon. See, here it is, Docker service. That's pretty cool, right? So daemons are nothing more than kind of like, I guess you could think of them as background services that provide a, for the lack of a better word, a service to the things that we run on our Linux system. All right, so let's go ahead and run the Nginx program, and we'll see what that system service looks like. So sudo apt install Nginx. And we'll do sudo apt install Nginx, which will install using our package manager. We need to update first. So sudo apt update. Oops. Okay, so let's clear the screen to get back up the top. So let's try that again. Sudo apt update. And then a lot of times when you want to run multiple commands at once, we'll do it &&, or you can also do a semicolon, and then you can do another command. So you can do sudo apt install Nginx. And that runs those two commands all in one. So that's pretty handy too for when you're trying to string commands together. Okay. All right, so now let's run the list unit files again. So we'll do sudo systemctl. So systemctl, by the way, is just another command and a utility that we can use to look at our system, for the lack of a better word, our system services. So systemctl indicating that it's a command line utility. And so systemctl, you'll see a lot when trying to interact with some of these system services. Systemctl list unit files. So last time we did list units. So this time we'll do list unit files, and then we'll grep for Nginx. So this will give us the list of services that are enabled or disabled, and then also if they're enabled at runtime, because a lot of times you can start a service, but once you restart your machine, it won't be enabled by default. So that's what we're seeing here. And if we took out that grep, we could see all of them. And they're just a similar format to what we were looking at before, but just in a nice little table format here. So it makes, it's a little bit nicer for the eye. So here we can go through from top to bottom all of our system services and what they, if they're enabled or if they're not enabled, or if they're static. Static just means they're kind of they're not loaded. They're just kind of hanging out there in the background, waiting to be enabled and loaded into the system. Okay, so I can just hit Q, or I was just hitting the space bar to go through that list, just kind of like I did with the last command, and I can hit Q to quit out there if you don't want to go to the end. Okay, so now that we have the Nginx service installed, as a part of the package manager, reason why we use the package manager and the reason why it makes it so cool is because the package manager automatically enabled that service and loaded it in so that we can start using it right away. So that's one of the cool things about a package manager. So let's see our status of just that service. So systemctl again, and then we'll just do status Nginx. We can use the full name, so nginx.service, or we can just do Nginx because there's an alias to that name. And let's see. Try that again because maybe my font size is a little bit too high. There we go. So if you can see, I just changed my font to a little bit smaller font, so hopefully you can see. But we have an active service, it's running, and that means we can immediately start using our Nginx service. And there's two kind of processes associated, or two PIDs, as they say, associated with this service. And it's right in the middle there. 25124 is the PID for the master process, and the 25125 is for the worker process. So that's what that's called. All right, so if we wanted to stop the service, we could just do systemctl stop nginx, and we know now it's inactive, and now we don't see that active anymore and running. We see it inactive and dead. See right here. So now let's clear the screen, and we can restart it by just doing start, or instead of doing a stop and restart, instead of doing a stop and then start, we can do a restart as well. So that works as well. So now if we do a status again, we'll see it's back to active and running. So that's exploring one of the many common system services that you'll see in a web server, at least, regarding Nginx. We could do the same thing for any other service like Docker. So we can do Docker and see that that's active running as well. We can run these same systemctl commands with any other system service. All right, so on to the third one where we want to take a look at the logs, right? So now that the Nginx service is available, and usually it's, so if we do, let's see, curl localhost, it should be on localhost, and then there you go. There's our Nginx welcome page, which is what we expect to see when Nginx is installed directly on the system. And then, so we use curl for that, curl localhost, and localhost is just another name for the current system that I'm on, localhost, or 127.0.0.1, that's localhost. And so yeah, now that we have Nginx up and running, we can take a look at if there's any logs in there. So we can do sudo journalctl, and journalctl is a lot like systemctl, but allows us to kind of navigate our system in a way that outputs the log from that service. So systemctl, just think of it like this. Systemctl can allow you to detect if the service is started or stopped, or information about the service itself. And then journalctl allows you to discover the logging information about that service. So journalctl logging, just make that connection there. So journalctl-xe allows us to go through all the logs for that. Well, for all the services, really. I didn't indicate any specific, but I can do a grep Nginx, and I can search for just the Nginx logs, and that's just a neat function of journalctl. So I can, kind of parse through these logs, see if there's any errors, and see what my Nginx service is doing. Cool. All right, so let's get to working with Git, and let's hurry up and create, not hurry up, but let's quickly and easily create a Git repository, and then see how Git works in the grand scheme of things. So if you don't know already, Git is a version control system. Version control system allows you to work on files inside of a team. So multiple people can be working on the same file and have that file checked out and be able to create different versions of that same file. So it's not version control indicating that files are going to be versioned. Version control is also used when working on software to develop kind of a branch, or we call them branches, but they're sometimes referred to as kind of just iterations of the original code in which we started with when working with our and building our software application. And then that's where kind of we can package that up, package all of our source code up into a release and be able to publish that release as well. So the release is kind of the packaging up of all of our source code, which may or may not be in version control. Yeah, let's learn by doing. So let's go ahead and make dir -p, and let's do a new repo. Let's say I want to create a new repo, and we can change directory into that new repo. And to establish this as a Git repo, we can do git init. So we'll initialize this empty Git repository. So if we do ls-al, we'll notice we have this .git folder, which is a hidden folder that now indicates that this is a Git repository. And now we can start to utilize some of those features of version control and work on some files and implement that into our version control system. So let's touch file1.txt, and now we notice because we added this file, now this file has automatically been added for tracking. What that means is if I do git status, this is because this is a new file, having initiated this as a Git repository, this file 1.txt needs to be added into this version control system to let the version control system know that I'm now working on this file. This is a file that's a part of my source code or my directory of files that are comprised of this application that I'm working on. And this is important because this not only tracks the file through its life cycle and allows you to not only iterate through the versions of the file, but also revert and be able to create multiple copies and kind of iterations, but also working with teams and being able to, effectively share this file and be able to work on it with other people. So I can, make changes, and then I can, send that up to the version control system, and then this other person can work on it, and then they can send it back into the version control system. And so we have this, kind of this main line of communication back and forth, but also this main line of files, of structure, of the structuring of files, I guess you could say. And so we can work on these files together, and just helps you to iterate faster through working with these files over time. And then, so now that I've discovered that having done the git status command, I've discovered that this file is untracked. So I want this file to be tracked by the version control system. I want this to be tracked. So I do git add, and then I can add file1.txt to be tracked. So now I do git status again, and I notice that this file is now being tracked. It's now part of the system, and it's now we're now keeping track of any changes to the file, anything that happens to the file. It's being tracked, and that's the beauty of Git, is that we don't really have to do anything special. We just tell it, go ahead, Git, go ahead and Git, go ahead and Git and track this file, and we're off to the races. So if you notice, it says changes to be committed. What does that mean? So changes to be committed means that once you commit this file, it gets let's see, it gets committed to a branch, whatever branch you're working on at the current time. So let's do git branch and see. We haven't created a branch yet, so we can do git branch. I can't see because there's a thing on the way. Git branch, and then a -b, and then main. Git checkout, sorry. Git checkout. Okay, so now if we do git branch all maybe. Let's see, git branch, never be afraid to use the help menu, folks. So help, and then all. Yeah, -a. Okay, I'm not sure why that's not pulling up our branches, but nonetheless, let's move on. So now that we have this file that has been added to our version control system, but it hasn't been committed yet. So we want to commit this to the branch that we're working on. Maybe once we commit, we'll see the branches because there's nothing on the branch. So maybe that's why we're not showing the branches. So let's do git commit -m, and then we'll just do initial commit. All right, and then it tells us that we haven't set our global user email yet. So we'll do that real quick. So need to know who we are. So let's just do, I'm just going to enter this information for myself real quick. Global user.name, and then I'll do, and then try to commit again. There we go. Boom, there we go. We got our branch information because we populated the branch. That means that we can see our branches now, which is good. All right, so now that we've done that, we can do status again. Oops, git status. And then we see that our let's see, nothing to commit, working tree clean. That means that we've committed all that we can commit. There's no untracked files or tracked files. And now we can go ahead and tell our partner or tell our colleagues that we're working on this application with, we can tell them, go ahead and utilize this file, change it however you wish, and then you can also commit your version to the main branch. Yeah, main branch. So that's a little bit about commit. Again, I have the commit cheat sheet, so feel free to go through that. And I got the commit cheat sheet from this GitHub page here. And then you could further your education about Git, and you can learn a little bit about GitHub and how that comes into play here, which is just a place where you can share publicly what you're working on, or what files you're going to share with the world via GitHub. So that's kind of how I created this repository here for you. And so you can take a look at GitHub as well after this workshop. Okie dokie. Wow, that was a lot. Let's take a little bit of a break, yeah? So let me check if there's any questions. And I don't see any questions. So hopefully everyone's on board and be able to follow along. Have we really been on for 2 hours already? Wow. Okay, so we're gonna take a 10-minute break. And so question just came in. Any idea how to push changes to an existing branch and not the main branch? Yeah, so I didn't have any branches. That's why I pushed the main branch. But let's see, if you had a different branch, let's just go through that real quick. So you may have seen if we do git help and then do, yes, if we search in here branch, we can specify the branch to commit to a certain branch. So let's do that real quick. So git checkout B, and then so the -b just means to switch to that branch after I create it. Let's do a secondary, or let's do something more realistic. So let's do a feature branch. So now we have git branch, and then we could do, we have a main branch and a feature branch, and the star indicates that we're currently on the feature branch. So let's do a touch file2.txt, and now we see git status. And now we have file2 that's untracked, so we'll do git commit and -m, and then we can do a good little message. We'll do git add first, sorry. So git add file2.txt, and then we'll do git commit -m, and then we'll do file2 commit, and then we'll do git status again, and git status, and there we go. So now if we do git branch, we see on the feature branch is, we can do git ls. What is it? Git show. Yeah, we can, I mean, we can just see what's being tracked here. So git show. Yeah, and then, so that's the information that's in this specific branch, and then we can do git checkout main branch, and then we can see git show over here, which is a different set of, file one as opposed to file two over on two different branches. Does that make sense? So we can take a 10-minute break. Okay. Yeah, so now that, pushing changes to two different branches just means, doing a git checkout to feature branch, and then doing the git add, git commit over here, and then, git checkout main branch, switch back over, and then make your changes over here, commit to that branch. So you have to be on the branch to commit to it. And so that's how you commit to different branches. So I hope that makes sense. All right, let's take a 10-minute break. And so I will be back after 10 minutes.
Cool. So let's take a 10-minute break and make sure to be back after 10 minutes because it's Docker time after 10 minutes.
Yep, fun stuff. We'll see you in a few. And we're back. All right. We are getting back from a 10-minute break there after going through Linux, everything about Linux for 2 hours. That's a lot of stuff. I hope you're able to stay with me there. But now we're going to dive into Docker, the fun stuff. So Docker, if you don't know, is a container runtime, but also it's a company, but also it's a suite of, it's a software suite. Let's talk about, okay, so we can't talk about Docker without talking about virtualization, right? A lot of times we, pardon me, a lot of times we compare containers to VMs, virtual machines. And so let's talk about virtualization for a little bit. I always like to start off with a simple example because it's kind of drives home the point of what virtualization is all about. And so in virtualization, there are two different types of virtualization, by the way. A type 2 hypervisor can run on any laptop or desktop. So just picture the machine that you're viewing this on. So viewing this workshop on the machine that's currently in front of you. Picture installing a hypervisor on top of it. So common hypervisors are like the most popular one is the VirtualBox, right? So VirtualBox or any hypervisor like that, whether it's Hyper-V, Hyper-V for Windows. And so you can install a hypervisor like that on your laptop or on your desktop. That then allows you to use what's called virtual machine images to create virtual machines. So you have this image of a virtual machine, basically taking hardware from your laptop and being able to turn that into software to the point where the virtual machine that's running on top of your hypervisor is using a portion of that hardware and software, or that hardware, both CPU, RAM, disk, from your laptop in order to run. And the virtual machine image can be created to create snapshots, to spin up new VMs, to essentially get to the point where you're not having to rely on hardware, so that if your laptop crashes, you can still take that VMI, that virtual machine image, take it somewhere else and run it on another hypervisor somewhere else. Let's say you get a new laptop or something happens where you are, your laptop crashes, whatever the case may be. The idea there is that we're using this hypervisor as kind of a layer of abstraction, so that you're no longer depending on your laptop and your laptop alone to run, which means that everything becomes software behind the scenes, and virtual machines are much like a Linux system, and just a grouping of files that allow you to run this operating system on top of a hypervisor. And so that also allows you to create different operating systems, right? So I'm not limited to the operating system that's installed on my laptop. I can also have each distribution of Linux installed. I can have Windows or whatever the case may be, different operating systems, all running at the same time on that same hypervisor, all sharing resources from your laptop. Now, another type of hypervisor is what's called a type 1 hypervisor. So we'll we'll pull out your laptop for a second, and we'll put in something called a VMware ESXi, which is a type of hypervisor, which takes out the underlying operating system. So on your laptop was an operating system, right? On your operating system, you installed a hypervisor, which allowed you to create other operating systems. In this case, VMware ESXi or Hyper-V, this is what the cloud vendors use to create their virtual machines, and takes away a lot of that unnecessary space and resources, so that you're just interacting with the essential bits that are the hardware that you're trying to use, the infrastructure, if you will, that you're trying to use in order to create virtual machines on top of. So virtual machines, essentially, let's just break it down to an operating system, libraries, and binaries, right? So this virtual machine has, on top of, as a part of the kernel, let's say, we've talked about the Linux kernel, you have the operating system, libraries, and binaries, and that all is comprised of the application that you want to run on your Linux system, right? So whether that's Nginx, or whether that's a text editor, or whether that's a web browser, or whatever the case may be, you have the combination of these three things in order to run your application. In addition to that, and in terms of a type 2 hypervisor, again, going back to the example, which I think is a little bit more easily understandable, in terms of a type 2 hypervisor, which is a hypervisor installed on your laptop or your desktop, a virtual box or otherwise. Pardon me. That type of hypervisor, in addition to the you're on top of the operating system, you have this this layer, which essentially is the container runtime layer that allows you to utilize things like Cgroups and namespaces to isolate those application binaries and libraries, right? So again, those binaries and libraries that are normally installed directly on the kernel itself, and as we looked at before, are just a series of files either in the bin directory or in the etc directory or wherever they are on the system, or the opt directory, whether they're a single binary or not, those normally, as of what we've looked at so far, are installed directly on the kernel or directly on the operating system. This kind of Docker layer that we're introducing now allows you to encapsulate those binaries and libraries into a tiny little package, hence container, tiny little container, and run multiple copies of those on top of the same system, right? So not only are we restricted to, only installing Nginx, and we can only have one copy of Nginx and one version of Nginx running on our system at the same time, we can have multiple copies of that isolated in its own little environment inside of a container. So that makes it really, really useful, because we're not having to replicate the operating system over and over and over again like we would with a virtual machine image, So we're only taking the binaries and libraries, the only necessary bits in order to run our application, and we're only packaging that up into our container. We're not including any other unnecessary files, directories, services, whatever you want to call it, nothing more, just the necessary stuff that's required to run your application. So that's the message that I want to drive home here. So let's take a closer look. Inside of, inside of each container is obviously the binaries and libraries that we just described, but we're able to obtain this encapsulation of those individual binaries and libraries due to a feature called, it's primarily namespaces and cgroups, but namespaces, namely, which allow us to only see inside of a certain environment inside of the Linux kernel, if that makes sense. So we're taking a portion of our Linux operating system and we're creating a different and isolated environment, which is essentially, it has no view of outside of that namespace. There's no, whatever's inside that namespace, it stays in the namespace and you can't see outside of the namespace. And so the namespace allows you to take things like CPU, memory, and certain types of processes that allow the kernel to run and encapsulate that into kind of its own environment, right? And then Cgroups allow you to limit the CPU, memory, and so forth that's being used inside of that namespace. So Cgroups allow you to limit the memory and CPU so that your single container is not utilizing all the available resources, which means not allowing your machine to come to a halt. You know, you're not consuming all of the memory that's available on the host machine. You're just using whatever the Cgroups allow. So that Cgroups allow you to limit namespace. Namespaces allow you to see, allow you to create that encapsulated environment that the container only knows what it can see because it's only within a certain namespace. And then you have other namespaces, which are user, UTS, IPC, net, PID, and MNT. And user is user namespace, so the users inside that namespace aren't aware of the other users that may be on the host system. The UTS is responsible for the host name and domain name. So you can create your own, you create your own host name for this container. IPC is, I lost my place here. Trying to follow my notes so I can keep on point here. Okay, so the IPC namespace, as I was saying, is for the processes for the kernel. The net namespace is for networking. The PID namespace is for process ID, and then the mount namespace is for mounting or for storage. So all that can be taken from the original kernel or the host system, as we say, and encapsulated into its own environment. So this is all the container knows, this is all the container sees, and therefore it's very similar to virtualization in that way, but different because we're utilizing the same kernel or the same operating system. We're not replicating that operating system over and over and over again. Okay, so as a part of kind of learning as we go here, I mean, I thought about when trying to create this workshop for you guys. I originally thought, yeah, we can just go through a series of Docker commands and we can learn Docker. But I thought it would be, on second thought, I thought it would be really cool if we could go through and take a look at how Docker actually does this. So we can see behind the scenes without using Docker directly in the Docker CLI. How can we see behind the scenes what is a Cgroup? What does it look like? And what is a namespace? And how can we create a new one? So that's what we'll do together. So we'll create a new Cgroup, limit the memory that the container allows, and then we'll also create a namespace, and we'll create a namespace in the UTS and PID namespace, and then we'll also use something called chroot or chroot to create a new file system for essentially a container, but we're not going to be using Docker. So we're kind of getting a behind the scenes look here, so it'll be fun. All right, so first things first, we're going to switch over to a different environment here on the killercoda.com website. And so in your address bar here in your browser, just delete Ubuntu and replace it with Kubernetes. So again, that's killercoda.com/playgrounds/scenario/Kubernetes. And not that we're going to be using Kubernetes, but this environment already has Docker installed and has everything that we need to go through these examples, with Cgroups, namespaces, and beyond. So again, killercoda.com/playgrounds/scenario/Kubernetes. So we don't have to worry about when our machine restarts and we run out of time. We don't have to worry about installing everything over again. We can just have it set to go. All right. I shouldn't have done that. Okay, just waiting for my command prompt to come back here. Not sure why it's taken so long. Because of the high demand, please reload this play. Okay, reload. Uh-oh. Can't handle us. Maybe we should go back to Ubuntu. Install Ubuntu. Come on. Do. Oh, Ubuntu is doing the same thing. Okay, I'm not sure if anybody else is having the same issue.
Can you check Kubernetes? Can you check Kubernetes now? It loaded for me.
Okay, I'll keep refreshing. Okay, here we are. And don't pay attention to the Kubernetes stuff too much just yet. I mean, as far as today is concerned, but so let's get into Cgroups. Okay, so let's take a look at the types of Cgroups that are on our system by default. So let's see, this is with every Linux operating system. So I guess I could have included this with my Linux portion, but this is just interesting to see. So in the sys directory, fs, and then cgroup, we'll see all of our cgroups. So we can see there's a cgroup for CPU to limit CPU. There's one for memory to limit memory, and there's one for everyone in between. So these are all of our cgroups that are part of every Linux system. Cgroups is, I think, introduced, decades ago. So I won't try to guess the year, but or the version or the release. Okay, so let's take a look at the memory.
Can you increase the font size?
Oh, sure.
Perfect. Thank you.
Yeah. All right, so let's take a look at the memory cgroups. So there's a lot of cgroups that are inside of memory to contain all those limits. So not only are we limiting memory, but we're utilizing memory stat, memory sloppiness, usage in bytes, usage hierarchy. So all these things are available to limit using this particular cgroup. And if you don't have any other cgroups created, every different process that you create will utilize this cgroup. For example, if I create a process, by default, it's automatically using this sysfs cgroup memory cgroup. If I create a new cgroup, I can specify how to use that specific cgroup instead of the default cgroup. And let me show you what I mean. So I'll clear my screen. And so if I change directory into sysfs cgroup, let's go ahead and create a new cgroup. So it's very simple to do. Make dir, like we learned before, memory, and then I can name this cgroup whatever I want. So I'll name it Chad. And then automatically, which is pretty cool, if we go into memory Chad, or if we list the contents inside of that directory, we'll see we've already created a number of these same cgroups that we saw inside of the memory cgroup. So we've kind of cloned the memory cgroup automatically by just creating a new directory inside of that memory directory, which is pretty cool. All right, so we can compare. So we can compare what these cgroups, how they respond to certain processes coming up, and we can measure what the cgroups look like before we start up a container and then after we start up a container. So let's just see what that looks like real quick. So I'm going to change directory back to home, and then I can do, well, first I need a particular set of tools. So let's go ahead and install those using our package manager like we talked about before. So app install -y, and then cgroup -tools is the name of the tool set that we'll be using. And inside of there, we're going to be using something called LSC group. So now that that's installed, I can use LSC group memory to take a snapshot of my memory cgroup. So let's do that. And we'll just do a before.memory. And then we'll start up a container. And we'll get to this in a little bit more detail in the coming lessons, but we can just start up a container using Docker, using the Docker CLI. So we'll type in Docker container run, and then detach for running the container in the background. And then the name Nginx, we'll just Nginx, and then the image we're going to use is Nginx. Don't worry too much right now about these commands, because we'll go through it again when we discover Docker in a little bit more detail. But for right now, we're just trying to run a container. This is a quick way to do it. So let's go ahead and run that. And then we'll take another snapshot with the LSC group, memory, and then we'll call it after memory. Okay, so now if I list the contents of my directory, I have before and after. So let's take a look at the difference. So let's clear the screen and we'll just do a diff before.memory, after.memory. So we're gonna take the difference. We're only gonna output the difference of those two files, memory. And the difference is there's this system.slice. And what is this system.slice? Well, it's relative to the root of the memory group, but it's essentially taken a part of that C group and it's kind of dedicated it to this process now, this process that was spun up from Docker. So we're utilizing the same C group, and if you see the reference to memory here, we're using that same C group that we're just taking a look at to limit the memory that's being used for this particular container. Okay, and so we can see the limit that it's placed on the this particular container. We can look at it from outside of the container, but let's look at it from inside the container first. So from inside the container, we can take a look at this C group, and we can go docker exec. Again, don't pay attention too much about what docker exec means right now. We'll talk about this later as well. We'll do Nginx because that was the name of our container, and then bash to get a bash shell to inside of this container. So now we're inside of this container, right? So now we can look at the C group that's created for this particular container, right? Every container is going to have its different slice, for the lack of a better word, of this C group namespace, right? It's going to have its own kind of limits that are placed on each container. So inside of this container, let's look at the proc directory and the $$, and then C group. And we'll take a look at the last one here, which should be the same as this one that we found up here. So ends in CF50, CF50. So system.slice docker starts with a D1E. Yeah, it's the same. So this indicates that we're using the same C group that we can view from inside the container. And let's go exit out of this container and look at it from outside of the container. And so if we go back to sys fs C group memory, and we can cat this out, system.slice. Let's clear the screen, sorry. So system.slice, and then docker, and then it was I already forgot it. Okay. Let's see. So diff, and then let's do tilde, which indicates our home directory before, and then tilde after. Okay. So we want to cat this out. So let's cat it out. System.slice docker d1 is a directory. That's why we're catting it out. So okay, so I should have done ls there. So let's fix that, sorry. Docker d1. Yeah, okay. So does this look familiar? Okay, so this is a slice of the Cgroup, meaning it has its very own set of, memory limitations for this particular container. Just like we took a look at the Chad's, Cgroup that we created, or the memory, or what's in the current directory, which is just the memory directory inside of our Cgroups directory. And so I was trying to cat out memory limit. That's what I was doing. So that's the memory limit that's been placed on our Docker container. So so let's take a step back for a second. So we've looked at how to create a Cgroup. And if you create a Cgroup inside of the memory Cgroup, let's say, if we create a directory inside of the memory Cgroup, it's kind of like cloning that memory directory. And we effectively did the same thing when we created a new container, or at least Docker did. We didn't do it manually, of course. But when we created a Docker container, it also created a new memory Cgroup. And we were able to limit, or we are able to limit the memory using the memory.limit in bytes portion of that Cgroup to limit the amount of memory that this container has access to. So we see it right now as it's in bytes, of course. So 922.337. It's quite a big. I think it's like 9 gigs or something. But that's taking up the whole memory of the host. So how you can restrict that, and maybe you don't want to give it as much memory, maybe you want to limit it even more, we can take a look at changing that. So in Docker, we have an option. So if we do Docker help, for example, and we scroll up a little bit, we have an option to use or Docker run, I should say, Docker run help. We have an option to use the memory. Did I pass it? Yeah, memory, which is a memory limit. Okay, so if you're still with me, let's go ahead and start up a new container, but this time we'll limit its memory. So let's go ahead and do that. All right, so we'll do Docker container run again, and then detach, and then the memory, which is just the -m, and we'll do 6 megs, just to limit this to not consume the entire host. And then the name, we'll name it Nginx 2, and then the image that we use is Nginx as well. Okay, your kernel does not support swap limit capability. Memory limit without swap. So let's try something less maybe. Let's just create, let's not, let's delete the other machine that the other container that we created. So docker rm, and then force, because it's running, Nginx. No docker ps. Oh, it is running, okay. Oh, that was just a warning. All right, anyway, we created a second container, which is running. It just gave us that warning about the kernel being able to limit it without us having to specify the memory limit. So now let's go into it and see that the memory has been limited. So Nginx 2, and then bash, get a bash shell to it again. All right, so we can look inside here again at the cat proc $, and then Cgroup. Okay, and there's our Cgroup again, and let's see if we can get a little bit more information on that. So let's try to dive into system.slice. I don't want to have to type this whole thing out. And then memory dot limit in bytes, not a directory. Memory dot limit in bytes. Okay, an easier way to do this anyways would be to take another before and after, or another after to be specific. So let's do lsc group memory. Actually, let's, just so we can view one container at a time, let's do docker rm force nginx. And so let's do the after memory again. So lsc group memory, and then, well, let's take a look at it as it is. So if we cat out the after, cat out after, and then we'll do lsc group memory and overwrite that. Okay, I need to do this. And let's take a look at that again. And then the diff, well, all right, so because we created that new container, it should have created a new memory Cgroup, right? So we can just cat out system.slice. All right, let's do the LSC group and then cat out that after memory. And so we can just take this Oh, I'm getting stuff from the Kubernetes side. That's why this is full. All right. Maybe I shouldn't have used this particular environment. I did practice this yesterday though, so. Yeah, so system dot slice docker, and then yeah, docker, and then memory dot limit bytes. Okay, we finally got the output that we're looking for, which is the 6 megs that we limited our Docker container to run. All right, so the idea there was to see that this slice of the memory C group exists inside of a container, or you can see it at least inside of a container and outside of a container. And also, you can change that C group around to change the limits of memory in this case to affect a certain container, and in particular with Docker, it's just by using the -m flag. But we saw how to do that, which is very important, right? Because not only do we know that Docker uses C groups as a part of creating the container, but it's important to know, that this also affects our host system, the system that we're running on outside of the container. So that's important to realize as well. Sorry, that didn't go as smoothly as I had anticipated. All right, so in Docker, we can run a command called docker container top. Or docker top. Yeah, docker container top, and then the name of the, yeah. Sorry, you have to give it the name of the container, of course. So this allows you to see, because containers are essentially just a process running on the host system, this allows you to see what that process ID is. So you do docker container top Nginx2, and Nginx2 is the name of our container. And let me, I can't see this very well, so I'm gonna do this for the time being. And so we have 2 process IDs associated with this container, one being the root and one being systemd. So this is the process ID 38437. So let's take a note of that. So let's see, because we're going to do something with this. So 38437. And so for any new processes that get created, what we can do is, instead of what we did before, which is, create the container with that memory limit in mind, we can do it so that any container that's created, or any process for that matter, any process that's created already takes into account that memory limit. So we are in the memory directory, and so let's go into that memory C group that I created before, which is just named Chad. So now we're in the Chad directory, and I am going to echo a number. So I'll do the 6 megs that I specified before for that container, 629 1456, which is give or take 6 megs. And I'm going to echo that into the memory.limit in bytes. Okay, so we can cap that out, memory limit in bytes. And now, instead of having a default limit of the entire host system, so if you remember that number before was like 9 gigs or something, it's just limited now to 6 megs, which is 629,000 bytes, give or take. All right, so this is how we do the reverse of what we just did, which is limit the cgroup from the very beginning, right? It's kind of hard to do with Docker because it creates its own cgroup, so it's a little bit different. But if we were creating a cgroup manually, like we are, we could take into account that limit in advance, so that every new process that's spun up will inherit that memory limit in bytes. And now how we can relate that to this process that we discovered, the 38437, is that we could echo that process ID, so 38437, and then we can put it into the actively running cgroup process as a part of the kernel, which is simply named cgroup.procs. So cgroup.procs right there. So that's that will be able to effectively apply that memory limit to that running process. So that's how we can do it in the reverse order that we did it before. You with me so far? Thumbs up. And then finally, we can see, in terms of cgroups, that is, finally we can see if we cat out the proc directory. Now again, because I did the /, it's pertaining to root. So we're catting out the 384 process that we discovered after running the docker container top command, and then cgroup, and then we can grep for memory, and we should be able to see it in there as well. Yeah, so this now says that this process is no longer using the memory cgroup, it's using the memory chad cgroup, which is a brand new cgroup that I've created manually. And so now it has that limit because I've set this limit inside of my chad cgroup. So that takes effect immediately, and that's at the kernel level. Cool. So let's get into namespaces, and we've been working a lot in the cgroups namespace, but we can easily take a look at all the namespaces that are available from our command line by just typing in ls/ns. And so this is running as root, so we're seeing a lot more happening here. But essentially, these are the main namespaces. So cgroup, PID, user, UTS, IPC, MNT, and net, and UTS. Yeah, I already mentioned UTS. Okay, so yeah, they're replicated a number of times here because we're running as root, we're logged in as root, so we're seeing the entire system here. So we're seeing the Kubernetes side as it's creating containers for the control plane, and we're also seeing some of the containers that we created in Docker and all that. So we're going to see a little bit extra here in terms of the available namespaces. And so those are all the namespaces. So that's how you easily see the namespaces inside of Linux system. And let's create a new namespace. I think it's pretty cool. And we'll start by creating a new UTS namespace in order to change our host name. So like I said before, host name, right now it's control plane, but we can create a new host name that applies just to our namespace, if that makes sense. So we're gonna kind of do the same thing that a container does, or a Docker container, I should say, in that we're going to emulate creating a new host name using this new UTS namespace. So let's do it. So let's do this first. We've got the host name. We want to run a container to usually a container when you spin up a container with Docker. Usually the host name is a random ID for the for the host name. I'll show you what I mean. So I think we still have our other container running here. Yep. So if we docker exec in here, so we're basically just going to get a shell to the container. Don't worry too much about this right now. So if we get a shell to nginx2 bash, and we look at the host name of it, we'll see it's just a random ID, DEC06B64B888. So that's our host name for our container, right? So you can change the host name of our container, or let's kind of emulate that very same thing. You know, just as Docker did with having the host name be something different than our host name that we see on our host. We can do the same thing when trying to emulate that same thing and creating a new namespace. So with that, we can use a tool called unshare. So unshare, UNSHAER, ARE, I should say. So if we wanted to take a look at this, we can access the man pages for this as well. But using this, we can do lots of different things. So the unshare command, we can create a process that has a UTS namespace of its own. So that's what we'll do. So this requires elevated privileges. So we'll use sudo and we'll do unshare UTS. And then we'll just create a shell inside of that namespace. So according to this, we've created the namespace, but it still has the same host name as the host. And so we can change that very easily by doing host name experiment host name, and then we've changed the host name. So not too exciting, but you can see how we can from inside the container, essentially, or I should say, from inside the namespace, and we can see that we can change the host name and make it something different than the host machine or outside of that namespace. So the host name here is experiment. Host name here is still control plane. And we haven't impacted the host machine at all. We're just randomly creating new namespaces, and we can spawn them and kill them as we wish, and everything remains fine on the host system. Okie dokie. So so that's creating a UTS namespace. Let's create a PID namespace. And this will be kind of the last example for kind of the behind the scenes work here that we're doing with namespaces. So if you notice, again, if we exec into our Docker container, we'll see that if we run ps eaf, ps command not found, yeah, I have to do that, and then ps eaf. I was not fine with that either. Okay, so let's spin up another container. So docker force nginx2, and let's do docker container run Again, not important for memorizing these commands just yet. Just bear with me here. I can't see the bottom of my screen, so I'll do this. Docker container run rm it name hello Ubuntu bash. Okay, so I'm inside the container again, and if I do ps eaf t, I'll notice that I only see the processes that are associated with this container, right? So how am I able to isolate my container so that I'm only able to see a subset of processes? So let's take a look at how that's done from the outside. So let's exit out of our container and let's create a new process ID namespace. So, the process ID, kind of the answer to my, my question before, is that the process ID namespace creates this isolation so that you're not able to see beyond what the container is able to see in terms of the processes that are running. So that's what we get out of the box with Docker, but that's what we're kind of aiming for, and we'll kind of simulate that now. So we'll do the unshare command again. So sudo unshare and PID, indicating the PID namespace, and then we'll get a shell into that namespace. And so we do who am I to see who I am, and I'll run that a second time, and you'll notice that I can't. It says cannot fork. What does that mean? Okay, if I exit out of here, so because I was running that who am I command and as another process, so when I ran who am I, it was essentially another process. I wasn't able to spawn new processes on top of that, right? So I created a namespace for a process, but that process wasn't a parent in the parent-child relationship to the to be able to create new processes. So I could only create one, essentially. So I created a namespace for one process, but that's kind of the limit that I reached there. So let's take a look at how to fix that. All right, so, and we could take a look at kind of the hierarchy if you want real quick. So if we, let's run that command again, sudo unshare PID, and let's open a new tab. So I'm just gonna open a new terminal. At the top of the terminal there, you can just click on this plus sign and it'll open a new tab. We'll go back to the original tab in a second, but we can run ps space fa, and we can see kind of the hierarchy of these processes. And we'll notice the sudo unshare pid sh, the command that we just ran, is not a child of unshare like we want it to be. It's a child of sudo. So that'll make sense in 1 second. So let's try to fix that so that we can run the who am I command over and over again. Okay, sorry, lost my place. Okay, so if we run sudo unshare, and then this time we'll do PID and then tack on -- fork, and then shell. Now I can run who am I, and it spawns additional processes, being that it's under the root of unshare. So if we do the PSFA again, we'll notice it's no longer a child of sudo, it's a child of unshare. And that's what we want in order to spawn new processes each time we run the who am I command. Make sense? So there's a process hierarchy that is important, especially with the PID namespace, that all of this is created automatically with Docker, but until you dig behind the scenes like this, you wouldn't necessarily know. Cool, I hope that was cool. I really enjoy seeing the behind the scenes stuff like this, because I wanna, effectively what we're doing is we're trying to see how a Docker container is created. And through simulating some of these things, like creating our own Cgroups namespace, or creating our own Cgroups and creating our own namespaces, we can simulate what what goes on behind the scenes when Docker spins up a container. Because you can run Docker commands till you're blue in the face, but it's really important to understand the behind the scenes here, in my opinion. And if we look at the proc directory, we can see all of those numbers in blue there indicate a different process, and kind of, again, what I talked about before, which is Linux is just a series of files. This kind of proves that the process is not really anything special. It's just a series of files in the proc directory, which are comprised sometimes of processes that run in the background. So if we go to, let's see, a process that's running. So let's say our bash process, which has a process ID of 32618. We can take a look at that inside of that directory, inside of the proc directory. So we'll do ls proc and then 32618, and then boom, there you go. All of the files that are associated with that particular process and how it's able to run. Important one to point out here is the exe. Oops. So if you see the exe, which is a symlink to user bin bash, this is how we're able to execute our PS commands and everything that we are able to see from a process standpoint, is because of this exe, which is symlink to user bin bash. And because it is, and because it's under root, being that it's user bin bash, it's given a process ID under root. So there's that hierarchy that we were talking about before, that everything kind of spins off from root, and that's how we're able to kind of create those new namespaces from root, but also kind of as root we're able to see everything and see all of the different namespaces that we saw before. All right, so let's move on to let's move on to, as kind of a bonus walkthrough here, let's go through creating a chrooted environment. So a chrooted environment essentially means that we're changing root, hence the name, chroot, chroot. It's typed like this. And so a chroot environment changes root. What does that mean? So changing root means that if I change directory to any directory on the file system, and then I run chroot, I can no longer, after that point, view anything that's higher on the tree or higher in the hierarchy, right? So I like, let's say I'm in let's say I'm in /user/bin, right? So if I chroot this environment, this creates a new root. So from that point on, user bin is root. And I won't be able to view anything higher than that. So I could not cd back to just user because user bin is now the current root. So changing root is what is kind of the takeaway there. We're changing root and where root exists in the file system. So that's important to remember in terms of what we're about to do. All right, so let's simulate that a little bit to kind of drive the point home. So right now, let's change back to the home directory, and let's make a directory called Alpine. Alpine is also a distribution of Linux and is usually lightweight, used for security, and we'll get to using it when we spin up some more containers in the future, but just know that it's just another distribution. So Alpine. So let's change into Alpine, and then let's see, we need to pull down the file system for an Alpine, because here's the thing about changing root. If we change root, because root has all of our commands in it in the bin directory, and we're able to run commands like ls and cd and all those because of those groupings of files. If we change root, then if those files aren't available, we won't be able to run those commands, or our shell for that matter, because that won't exist in any new directories. Does that make sense? So because this kind of drives home the point even more that Linux is just a group of files, because if we don't have those files persistent, we won't be able to do anything. We won't be able to run our bash shell. We won't be able to run the commands that we're used to running because we don't have access to that file system. So let's kind of simulate that now. So I'm going to grab down the Alpine file system, and then we'll chroot into that so that we can have certain commands that we can use. So let's do alpine.tar.gz. That's the name of the file, and HTTP. So let's see. Instead of having to type all this out, let's just go back over to the repo that I was referencing before, and Alpine. And so you can just search for mkdir Alpine, or mkdir Alpine, or just Alpine. And then let's take this big link right here, which is the link to the Alpine operating system. And we'll copy that. And then we'll go back over to our terminal. And bump this up a little bit, clear. And so we'll download that file. So now we have alpine.tar.gz is what we renamed it to. And then we'll untar it. So xvf, and then Alpine. And now we have the extraction of that Alpine. So we'll change that. And then does this look familiar? It looks familiar, right? Because we already took a look at this in the very first slide of this workshop, in that this is the Linux file system. And these are the same directories: the bin directory, the lib directory, the mount directory, the temp directory. Everything is the same because this is a Linux operating system. Pretty cool, right? All right, so now we can chroot this environment. All we have to do for that is just do sudo chroot alpine ls. Actually, we have to, let's go out one level. So we should be back into our root directory. And then let's do, again, sudo chroot alpine ls. Okay, so it's not necessarily apparent here whether we're inside of a chrooted environment, but how you can tell is if I list out the contents of the home directory, and let's see. Oh, okay, so running ls. Yeah, okay, sorry. I got ahead of myself again. So sudo true alpine ls. So basically what we were doing there is we were changing root. So that root is the alpine directory, right? And then inside of that chrooted environment, we were running the ls command. So that's how we got the listing of our current directory. And so now, in order to simulate that a little bit better, instead of doing ls, we can do sh. So we can do sudo chroot alpine sh. And now, we didn't get the listing as you saw, but now we're inside of a shell inside of that chrooted environment. So how we can do that is, again, ls home, and there's nothing in home. And what else can we do? We can do, to kind of prove that we're in a new environment here. Yeah, we can run ps eaf, and there's no processes running. And so because this is the empty environment, so if we exit out of here and if we run the ls home again, we'll now notice that we're outside of our chrooted environment again, and then we can do ps eaf, and we get a number of services, processes that are running. Sorry. Cool. So that was a chrooted environment, which again is kind of taking a step back and looking at how is a container created and how does that behind the scenes, how does Docker do it in terms of creating an environment to which looks like its own operating system, which is essentially behind the scenes just a chrooted environment. So very cool. All right, so let's combine the last two. So chrooted environment combined with creating a PID namespace. So let's combine those last two things that we did. So let's do sudo unshare PID fork. Remember, we need the fork to be able to spawn new processes, chroot, and then alpine and shell. So now we can mount the file system. We can mount the kernel processes by just mount -t proc proc proc, and then we can do ps, and boom. Does that look familiar? That looks exactly the same as when we were inside of our Docker container, right? This is inside of a chrooted environment, inside of a PID namespace. So we're only able to see the processes inside of that namespace, right? I think it's pretty cool. If I had a round of applause button, I would give myself a round of applause. All right. Enough of the behind the scenes stuff, but I think it was really cool to see and really important for getting the fundamentals on how a container is created, right? Because we, just by running the Docker commands, we don't necessarily know what's going on behind the scenes. And to have that fundamental understanding that, oh, I've created a namespace before, so I know, how namespaces work, and I know how Cgroups work because I've created a Cgroup. It's really, great knowledge to have so that you can start to understand the inner workings of it. Okay, so now that we've gone through that exercise, right, and it's really cool to see, but now you can start to wrap your head around the benefits to using namespaces and Cgroups and all of those namespaces that we've worked with so far. You can start to understand why containers are so special or so widely used. So let's go through the main benefits of containers. So as you saw, because we were able to create a container both ways, really, with Docker and manually, we were able to deploy a container really fast, much faster than if we were to, spin up a VM with an operating system and wait for the OS and the BIOS and all that. So it's quicker to deploy. It's lightweight, so the size of that environment and the size of the container itself is megabytes versus gigabytes. So we're, like I said before, only utilizing a subset of those libraries and binaries. So the footprint becomes much smaller. And then repeatable. So something that we'll get into in a little bit are how you're able to recreate these Docker containers is through something called an image. An image is nothing more than the steps it takes to build, not build, but the steps it takes to run a container. So we'll take a look at images in a little bit, but it makes it repeatable, right? Because this container and the given steps to run this container are consistent between environments, between operating systems, between wherever you're running this, you're running it in the same type of way. And then portable, I can share these container images and store them in a repository and have people accessing them no matter where they are in the world. So that's pretty cool. So Docker, the company, has this methodology, and I think to a certain extent, the Cloud Native Computing Foundation has kind of adopted the same, I guess, innovation. It's build, ship, and run. So everything that is created with Docker has an over-encompassing methodology, or is all based around this build, ship, run idea. So building, meaning building Docker images. So a Docker can convert source code to an artifact known as an image. So that's what an image is. It's the steps to create a container. It's an artifact. We can ship it. We can use this kind of single binary type thing to deploy and build. And an image is ideally lightweight and portable, as we discussed. And then being able to ship that image through something like the Docker registry or the Dockerhub, or any Docker registry, whether it's private or public, and you can gain access to that and deploy from anywhere. So it's like the GitHub of containers, and so you can share and make that image available, like I said. And I mean, there's upsides and downsides to that, right? I mean, we are cognizant that every image that we might put on a registry may not be exactly ethical. There are some images out there that are very nefarious and will cause a lot of problems in terms of malware and introducing a whole host of other security issues into your environment if you run it. But we'll talk about security a little bit later. And then run, of course. So Docker containers, being that they're so isolated and they contain all the necessary bits and pieces in order for this container to run, and you can run that anywhere, and it'll run in the same fashion. It runs similarly between different environments. Okay, so let's get to utilizing Docker and to see all of this this Docker magic and get to running containers, right? So let's run 2 containers, an Nginx web server and an Apache web server. We'll stop and remove those containers after we're done. The second scenario is we'll create an environment, or we'll set an environment variable rather, sorry, and we will run a MySQL container and set a DB password. So we're gonna use an environment variable, pass into that container so that the, lost my place again. So the container knows that this is the password for our MySQL database. Okay, and the third exercise that we'll be going through together is to get a shell inside of a container in order to update the package manager on CentOS. And then the fourth exercise that we'll be going through together is getting the process ID for a running MongoDB container and compare that to the PID or the process ID on a local host, or I should say its host. Localhost can refer to, I guess, outside or inside the container. So, all right, so let's do it. So let's run 2 containers. All right, I'm just going to refresh my screen here to refresh my environment. All right. And we can start from scratch here. We don't have to install anything special.
Please, can you increase the font size a bit?
So, every time I do that, I need to, okay, I should remember to do that. Every time I refresh the screen, change the font size. Got it. All right, so we did a little bit of this before, but let's just go through it again as a review and to look at it in the context of Docker and getting very Docker specific now. So Docker, is a container engine, container runtime, and we'll run the containers in the fashion in which we just went through with creating namespaces and cgroups, but also, it's a CLI, and so we're able to run commands like docker and the subcommand to interact with our containers, is what I should say. And so we can interact with our containers and we can run our containers all at the same time, which is really nice. So if I just run Docker like I just did, I'll get a preview of all the available subcommands that I could run. We could also do Docker, oh my goodness, Docker version. And we'll see the version of Docker that we're running, 12.10.12. And actually, let me kind of demonstrate something there. So here we have 2 kind of elements to Docker. Inside of the Docker engine, we have a client and we have a server. So client is the client that you'll be using to interact with Docker, right? So it's the client, whereas the server is what's running Docker in the background and creating namespaces, creating the chrooted environments, creating all the stuff that we that we know to be consistent of a container, or what consists of a container, I should say. And so just remember, not really important for the context of running Docker commands and what we're doing, but just remember there is a client and there is a server, and there's a difference. Okay, so let's do this. Let's run our first container, or we've already run a container, but let's do it properly, yeah? So let's do Docker. Okay, so I wanted to point out one other thing before we run a container, sorry. So if we run Docker, right, we get a list of all these commands that we could run that are available to us. Now, there's a difference between the commands, and the Docker has separated out these commands into management commands, which are usually a little bit longer, and just regular commands. So when I run the commands that I'm about to run, usually there's a kind of an alias to regular commands, there's an alias to the management command, or vice versa. There's an alias from the management command to a regular command. For example, docker ps is a regular command, right? Docker container ls is the same command. It's just alias to docker ps. They mean the same thing. They do the same thing, but there's just a, just remember that there's going to be sometimes two ways of performing the same or getting the same outcome, and that's because Docker has created this separate group of management commands. Okay, so Docker contain. I'm going to use the management, because I feel like I want to be explicit with what I'm doing here. So I'm going to use the management commands. Docker container run allows us to run a container, and we use the flag detach to detach our TTY from the container. So we can, for a couple of reasons. So we can run it in the background, and we can also get our prompt back. Excuse me. So we can continue to run commands with the container running in the background, essentially is what that means. All right, so we're going to run it in detach mode, and I can give it a name by specifying the -- name parameter or flag. And let's name this Apache. And I'm just going to put a line continuation character here, which is a \. It's the key above the enter key for me. And I'm just going to, this is just continuing the same command, but just because it'll look better, because I'm running out of room on the screen here. So I just want to make sure that this looks like I want it to look. And then there's also an option to publish ports to, I should say, from the host system to the container, so that when I go to access a certain port on my local machine, it allows me to basically poke a hole in the firewall to gain access to my container. So that's what publish means. So I will publish port 8080. So 8080 is going to be the port that's exposed on my local host. So this virtual machine that we're running this command on. And then 80 is going to be the port that is exposed on the container side. And an important thing to remember here is it depends on how the application is built to where it's going to actually expose that port or not. So in this case, because I know this particular container image and how it's built, it exposes port 80 and 8080. I know that this is going to work, but just keep that in mind in the back of your head. Just always be thinking, is how this application built, able to expose the application on a certain port or not? And we'll get into where to look for that when we go over a Dockerfile and how Docker images are built. All right, so 8080 to 80, HTTPD. HTTP is the name. HTTPD is the name of the Apache image, and will allow us to run our container with this image. And so we go ahead and run this command, and there's a lot of stuff going on right here. So let me explain. So with every Docker container, there's a number of, it's like a stack of, it's like a stack, one on top, a stacked layer upon layer of either commands or certain binaries, and all of these get stacked on top of each other, and they each add to each other, if that makes sense. So they we'll get to this in a little bit more detail in a little bit here, but what this is doing is downloading each one of those layers, and when you put those layers together, you get a container. What this allows us to do is have a lot of space and resource savings, because we can utilize some of these lower level layers for other containers. So for example, if I were to run the same exact command again to run another Apache, in fact, let's do that. So we have to specify a different port. Let's do 8081, and we have to give it a different name. But if we do this again, notice it was much quicker, right? It didn't have to go down and pull down those layers. It's already using existing layers and building on top of that to run our container. So we're not duplicating files here. We're not duplicating anything. We're utilizing those layers, and whether I add to that like I said, we'll get to that in a little bit, but whether I add to that or not depends on whether I add to those layers. So cool. Just think of it as a stack. A container is not just one subset of files. It's a stack of different different layers. I don't know how else to explain it, but yeah, it's a stack of layers that allows us to reuse those layers when needed. So anyway, so now we can run clear, and then we can run docker container ls, and we see there's our 2 containers running. And so these are our containers. I lost my place again. Sorry. Okay. Here's how we can see all of our running containers. So let's do docker stop or docker container stop. Either one will work. And Apache 2. So I stopped that second one. So let's do docker container ls. Oh, I only have one. Where did it go? So if I tack on the -a here, I'll see it as a stopped container. So just remember, the docker container ls will only show running containers. Docker ls -a will show everything, all containers. So that's what you need to add to your command in order to see all the containers if you're not able to see them, whether they're running or not. Okay, so let's go ahead. We were going to run an Nginx container too. So let's do docker container run detach name Nginx publish. Oops. Publish, and let's just for the sake of demonstration, we'll start to it'll start to pull this image down, and like I said, go through the process of stacking the layers, but it'll give us an error. See, it said port is already allocated, and that's exactly what I wanted to demonstrate there, which was we have to specify for the host that's running the containers, that is, we have to specify a new port for each container. We can keep the same one for inside of the container, because again, container is isolated, right? So it's not aware that these other containers exist. So let's just do 80. So this is why I use the line continuation character, because it's hard to do this over. Okay. So it's telling me that okay, so here's my Nginx container. Even though it gave me that error, it's still kind of not started up the container, but it created a container, a stopped container. So in order to create a container with the same name, I have to delete it. So in order to delete a container, we can do docker container rm and then the container name. And so we can delete that container, and now our previous command should work. Okay. All right, now we've completed the first exercise, which is to run two containers together. And just for fun, we can do curl localhost, and we can see the Nginx welcome page, and then we can do curl localhost 8080, and then we can see the Apache welcome page. So they're running as expected, so that's cool. All right, let's, so the direction stated that we have to stop and remove the containers after, so let's go ahead and do that. So we can do docker container rm, and then we can do the names of our containers. We can do multiple containers at once. So we can do Apache and then Nginx. I kind of did this on purpose, but you can't remove a running container, which is a good kind of fail-safe, but you can't remove a running container. So we can either stop the containers and then remove them, or we can issue the docker container rm and then a force command, or the -f, and then those will force those running containers to be removed. So if we do docker container ls-a, we only see that one Apache one that we created before. All right, so let's move on to the second scenario here. Run a container from a MySQL image and use the environment variable. Okay, so here's where we insert an environment variable into our container. So yeah, environment variable, yep, that it is. Okie dokie, so let's do it. Let's do docker container run again. This is how we start up containers. Get used to typing that in. Docker container run, we'll name this, what was it? I did say MySQL, okay. MySQL, and then we'll run this in detach mode. And instead of typing out detach, we can also do a -d. That's probably easier, so you don't have to type that out every time. And so docker container run, the name of the container is MySQL, and then we're going to run it in the background or in detached mode, and then we'll use the MySQL image. Easy as that. We didn't include our environment variable, so let's do that really quick. We would have had to wait for this image to download anyway, so it's good that we're doing this first. If we wanted to pre-pull images, which is something you can do, we can run the docker pull command or the docker image pull command, management command. So docker pull, let's do Mongo, for example, and it'll pre-pull those images. So you don't have to, so you can pull them down locally. So you're essentially downloading that image, so you don't have to, you can reference the one that's on your local machine versus having to download it every time from the internet. Or in this case, it's from the Dockerhub. Okay, so let's wait for this a little bit longer. I think we're going to use Mongo in a bit here, so it's not bad that we're pulling this down. Okay, so we'll run docker container ls, and we'll see nothing, so -a. And so let's do docker container rm, And then we can also hit the tab key on our keyboard, and we can get a list of what's available to delete, which is also could be helpful if you're looking at, tens and maybe hundreds of containers. So we'll do, the MySQL one. And so that's deleted. And then, so let's set our environment variable like we were supposed to do. So Docker container run and detached mode, publish. And usually the ports for MySQL are 3306. I just know that offhand. I think it's common information. And then we'll name this MySQL. And then I'll just do a line continuation character to continue my command on the next line. And then I'll do an environment variable. So this is specified by the --env flag. And so for MySQL, the environment variable that we need to set is MySQL _ random root password equal to yes. And then again, we'll use the MySQL image. And oh, it ran it right away because it didn't have to download the image. That was cool. So Docker container ls. And there it is. And let's see, we have to look at the logs. So we can do Docker container logs MySQL. And we should see that random password shown up here in the logs. Okay, to do the empty password, okay, empty password. Random password is what we're looking for. There we go. So generated root password, that's the random password that it gave us. So we'll copy that, and that's how we'll be able to connect to our MySQL database. Okie dokie. So that was the second scenario that we're going to run through. The third one is get a shell inside a container in order to update the package manager on CentOS. Okay, so let's do that. Inside a container in order to update the packages. Okay, so let's do this. So clear. So let's do a Docker run again. But this time, what we're going to do is we're going to run a temporary container. Reason why we're going to do that is sometimes you want to run a temporary container just to do some testing with curl or to troubleshoot some networking, whatever the case may be. You want to create something that's kind of inside of that same Docker container network that'll allow you to be able to troubleshoot as if you were a container. So it's always good to do that sometimes. I mean, it's a good troubleshooting tool for sure. I've used it many times. So in order to do that, we specify the --rm flag for remove, and that's going to remove the container, meaning it's not going to show up when we type in Docker container ls or ls-a. It's going to remove that entire thing as if it never existed beyond what we're going to use it for. So, and then the -it flag is what we're going to do next, and that will get an interactive TTY session inside of our container. And we used this before when we did the docker exec command, but this is a good way to make sure that you stay inside of the container and get a bash shell to the container or whatever shell as long as the container supports it. And you can operate inside of the, get a shell to the container, which is nice. All right, so IT, interactive terminal, is how I remember that. CentOS, and then 7. So the reason why I used the colon and 7 there was because sometimes images have tags associated with them. So maybe a similar image, but maybe it's version 7, or in this case, it's CentOS 7, so it's the iteration of that operating system. But in a lot of cases, there'll be a tag associated with an image, and we'll get into that a little bit more in a little bit here. But a tag will specify, what version of it it is, or what kind of release information is contained within that image. So it's a good way to separate your images out like that. And then bash. So bash is something that's included in this chrooted environment, right? Like we talked about before, and we'll be able to run it when we start a shell into our container. Cool. So now we're inside of the container. We can run hostname again and see that the hostname is different. Okay, so now we got to use CentOS package manager, which is a little bit different. So we'll do yum update. Yum is the equivalent to apt in terms of package managers for the CentOS, which is based on the Red Hat distribution. We'll just hit Y to continue. Now that we're updating the packages on this machine, we're able to see, this is only affecting the container, right? So we're not updating the packages on our host machine, because we would be using apt package manager for that, right? We're updating the packages that are unique to this container. So it's a very isolated environment, only pertains to this specific container, which is nice. Okay, as that updates, let's take a look at the fourth scenario that we're going to go through together. Get the process ID for running Mongo. There we go, Mongo. I knew we were going to use that. Okay. Let's go ahead and Control C out of this, and then we can exit out of that container because we're not going to use that container anymore. And so let's go through this scenario of using the Mongo container. So Docker container run, and then we'll name it Mongo for simplicity, and in detached mode and Mongo. Cool. So let's do this. Docker container ls, and we'll see our two containers running, MySQL and Mongo. And so let's do Docker container top Mongo, and we'll see the process ID for, to make this a little bit smaller. Yeah, process ID for this running container. Yeah, so for 48459, yeah, 48459. And then we can relate that to the process ID that we see from the host system, right? So let's exit out of the container. Connection closed. Oh, we were already exited out, sorry. Son of a gun, sorry about that. All right, so we'll do Docker. Let's increase the font size. Thank you very much. Okay, Docker container run name Mongo detach Mongo. I have to download the image again because it's a new fresh VM here. So wait for that to go through. Okay, all right, again, Docker container top Mongo. Okay, this is the process ID, from inside. This is the Mongo process ID from inside the container, right? Let's look at that from outside the container. So ps aux, and then we'll grep for Mongo. Cool, so it's 41275. And so this is kind of another instance where we're seeing, because all containers share the same kernel, right? This is essentially just another process running on the host system. So this is what we're seeing here when we're looking at the process ID from inside the container versus the process ID from outside the container. All right, so let's Docker container stop Mongo. We can stop that container if we want. And that completes our 4 scenarios. So let's check the chat messages real quick. No chat coming in. Let's move on. All right, so container image. So like I said, a container image, there's multiple layers of these pieces of a container image that may be comprised of, the binaries and libraries that are responsible for Nginx running, and maybe the binaries and libraries that are utilizing the apt package manager, and maybe the copy. Maybe we're copying something inside of the container, so there's another layer of the image there, and maybe we have another image. So this image not only contains the Nginx apt and copy, but also has the port exposed and adds a different, adds something different in terms of, updates to packages, or adds something new on top of the existing operating system, or the file system, I should say. And then additionally creates an environment variable, so on and so forth. So the important thing to remember here, and what I'm trying to demonstrate in this slide, is these are 2 completely separate images, but share the same layer, share the same layers. And so when we're talking about creating an image, and like I said before, when we did the Docker pull command, or when we did the Docker run command, and it pulled down those images for us, it's not duplicating any of those layers. It's able to utilize those layers. It's able to build on those layers and still create different images for the same layers, if that makes sense. So the point here is that these are 2 separate layers, these are 2 separate images, even though on the left-hand side of the screen, we have this with only 3 layers, but on the right-hand side of the screen, we also only have 3 layers, but it's utilizing those existing 3 layers on the left-hand side to build on top of it, right? 2 separate images, same layers. Therefore, we get some space reduction there, some efficiencies that are built in with images, which is really nice. So an image itself, again, is the app binaries and dependencies along with the metadata required to run the image. What that means is kind of what I talked about before, which is what a container is, right? So it's the only the necessary components for that application, whatever that application is doing, only the necessary components for it to run. And so there's no kernel or drivers or any other operating system pieces because it's utilizing the host kernel. And as we've seen, utilizing namespaces and Cgroups to create that layer of isolation on top of the existing kernel. So it's not, so it's utilizing existing resources, and that's why it's able to be so small and to only contain the necessary components that are required to run. So, and the kernel meaning, you know, the essential Linux, the Linux kernel, in that, you know, what contains, what is, you know, what is inside of the kernel that makes Linux run, right? We're not talking about all of the additional operating system components. We're talking about the kernel. So kind of peel that back and look at the kernel itself and see the kernel for what it is, which is a way of translating the software that we're using on top of the operating system to the hardware components below it, okay? So it's utilizing the existing host kernel in order to run, but those additional binaries and libraries are only required and are only there to run that application specific thing. Okay, so to demonstrate this, we'll go through a couple examples together. So we'll go through pulling 3 different Docker images, Python, BusyBox, and Redis, and we'll check the history of these images to see how these images have changed over time, which is a pretty cool thing that we can look at. And we'll also tag images. We can retag images to you know, have them be more meaningful, or maybe, you know, we're building an image that builds on top of a different image, so we want to tag that appropriately. So like a common one that I always use is Nginx with curl, because the Nginx official image doesn't have curl, so I like to use or no, it's BusyBox with curl. Sorry, BusyBox with curl. So I utilize that image a lot for, you know, troubleshooting and using curl. Anyway, so we'll use tag. We'll be able to learn how to tag images as well. Okay. Let me get set here. Oops. All right. Clear. All right, so we just did it, but we can do it again. Docker pull, and then the name of the image. How do I know the name of the image, by the way? I don't know if I talked about that at all. I know the name of the image because, for one, I'm getting all this from a specific, I'm getting this from Dockerhub, and I can literally go to Dockerhub, which is an image repository, which Docker uses by default, as you can imagine. And so if I go in here and I search for an image, so I'm going to pull down Python, for example. So here's you know, the Python image, and here's that same exact command that I was about to run on the terminal. So Docker pull Python. I can pull that because it's an official image. It's from Dockerhub, and that's where my system is pointing in order to get its images. And let's see, let's open up a new tab and do another pull. So Docker, oops. Docker pull BusyBox, and maybe a third tab. And we can do Docker pull Redis. Cool, so now that we've pulled Python down, let's clear the screen. And let's check out what's changed in this Docker image over time. So let's do Docker history Python. And we can see a number of things here, but this is, when this specific layer was added and when it was added, right? So let's see, we, or not, this isn't necessarily layers being added, sorry. This is, how this image is being used kind of over time here. So as of 2 weeks ago, we see kind of what the, first of all, what the size of the image is, and then how this has kind of changed over time in terms of the commands that are being run alongside this image, I should say, sorry. And this information that we're seeing here, this is called copy on write. And copy on write effectively means we're able to copy certain parameters to the execution of a particular image in order to make it more useful. So copy on write, it's an important, this starts with the scratch image up here, and then everything below is kind of a copy on write on top of that. All right, so then we can do, I think we can close these tabs. Yeah, so we can do Docker history BusyBox and see the same thing. And then Docker history Redis. Yeah, so this is just useful information. If you ever want to reference this for, being able to run certain commands inside of the container, or try to figure out what this container is used for, those are helpful for that. All right, so we can see a list of our containers that we've downloaded. So Docker images, Docker image rather, ls. And so we can see all of these container images we've pulled down. And let's go ahead and maybe retag them. So to tag an image, we do Docker image tag. I guess we could do Docker tag, and then Python. And then because we didn't specify a tag for this from the source image, that is, we have to specify it here. So we can do latest. And then I'm going to tag it for my username in Dockerhub, and then Python 1.50. Let's say, I just made that up. So, and then we can do the same thing for our other images. So BusyBox, same thing. BusyBox. And then BusyBox. And then let's do 1.20. And then we'll do Docker image tag Redis latest. Redis lates. Okay, so now if we do Docker image ls, we'll see 3 more images. Not that it's copying those images, because I think, as you can see, it still has the same image ID. It's not that it's copying the images, it's just referencing those images from the source image. And it still contains everything that that original image did, it just has a different tag. And then if we run this tag command again, let's say, yeah, we can just keep we can just keep running this over and over again. So got image tag, and then we'll create more tags of the same image. Cool. Alrighty then, so let's move on. Let's talk about a Dockerfile. So a Dockerfile are instructions on how to build an image. And so this is what a Dockerfile looks like. This is an example of a Dockerfile. It looks like one that creates the Python Docker image. And so we always have, Dockerfile has its own specific syntax, and it's always Dockerfile with a capital D, no extension, and always contains this specific syntax. So you see from env, the red letters there. So from env and run and env again and run again. So let's see what those mean. So the from, and this is required for all Dockerfiles, specifies the base image, the parent image, if you will, that's being used, that all subsequent commands will build on top of, right? So you got to start with something. The label, which is not pictured here, but we'll just talk about it. The label is another possible option for a Dockerfile, which provides metadata, and is a good place to include the maintainer info. So if you're the one that's building this, it's a good idea to put your name in there. env sets the persistent environment variables. The run runs a command and creates an image layer used to install packages into containers. And then the copy command copies files and directories to the container. The add also copies files and directories, but can unpack local tar files, so that's important. The cmd provides command and arguments for a container. Parameters can be overwritten, only one. You can only specify the cmd once. And you may be asking, what's the difference between cmd and run? Good question. So the cmd is used, well, the run is used for adding packages and installing necessary individual components, which you'll see kind of in our example over to the left there. But the cmd is used on more specific case-by-case basis. So cmd, because you can only specify one cmd parameter per Dockerfile, you're somewhat limited in terms of what you can use it for. So it's used a lot of times for single commands and arguments that you may want to run inside of your container versus running a series of commands, let's say. The workdir directory, or the workdir syntax is sets the working directory for the instructions that follow. So the workdir being like where your application code exists. So where inside of the container you're going to run all this stuff from. Arguments defines a variable to pass to the Dockerfile. Entry point provides commands and arguments for an existing executing container, and then the arguments persist for the life of the container. And so the entry point might look something like a entry point into like a bash shell. Expose is for exposing a port. As I mentioned earlier, not all Docker images have this expose, or not all Docker files have expose. So the application itself may not be exposed. Something to keep in mind. And then volume creates a directory mount point to access and store persistent data. So we'll talk about persistent data in a little bit here, but that's where you specify that. Okay, so workshop number 8. So we'll customize builds. Oops. Customize build and push. So we'll build a custom image that modifies the Nginx homepage, and we'll run it to test. We'll create a Dockerfile that follows a specific set of instructions to build and run, and then we'll push a container image to Dockerhub under your own account. And If you don't have a Dockerhub account, don't worry, it's totally free, it's totally easy. We'll go through it together. Okie dokie, so let's start. Let's go ahead and clear. And in our home directory, let's create, let's create a directory, mkdir, and we'll do the -p, and then we'll do, just name it Docker. So Docker, cd to Docker. So now we're in root Docker. I just don't want to, just want to categorize these files appropriately. So let's see. So we'll do, vim index.html. And I don't know a whole lot about HTML, but I do know that there's opening and closing tags. So I'll do HTML. And then I'll do a body tag. And then I'll do you did it. Just a message there for the people. Okay, or for us rather, because we're going to be running this. Okay, so let's create our HTML file. That's all good and well. So now we have an index.html, and so now we'll create a Dockerfile. And now we'll go ahead and make a simple Dockerfile. Okay, this is nothing too fancy. And so we'll do from, and we'll start with the Nginx latest, and then we'll set a work directory, usr share Nginx HTML. This is where the index.html is usually located in Nginx. And then we'll do a copy. So we'll copy index.html to index.html inside of the container. So index.html in our local path, the one that we just created, and then we'll insert that, or copy it, I should say. We'll copy that into index.html inside of this directory here, our working directory. Simple Dockerfile, but let's go ahead and save and quit. And in order to run this, we just simply run the command docker build, and then we can give it a tag. So let's do Nginx custom, and then a dot to signify where the Docker file is. And here we go, we're building our container, it's magic. Okay, so that was pretty quick and intentionally so. But let's go ahead and clear the screen, and we'll do docker image ls. And now we see here's our Nginx custom, and there it is. So let's go ahead and run it, shall we? So let's do docker container run, and then let's do in detached mode, and let's expose a port, and let's use our image. So Nginx-custom latest. Docker container ls. Okay, there it is. So if we did all this correctly, we should be able to curl localhost. Oh, we did it. How about that? All right. So we got back our customized Nginx image, which is pretty cool. So instead of seeing the normal Nginx welcome page as we have before, we have this custom Nginx welcome page, which we customized using the index.html. Pretty cool. Good job, guys. All right. What's the other? So we're going to build. Yep, we did that. We did build and run. Let's do another example, because this is fun. Okay, so let's do let's cd back one, and so we're gonna let's do this. Let's clone down some source code so we can work with some real source code to get an idea of what we're working with here. So in order to pull down some source code from a Git repository, or a GitHub repository, I should say, we can use the command git clone, and then we can specify the path to where that repo exists on the web. So we do https://github.com/docker/getting-started.git. Okay, now we have that directory in here, so let's change into that directory, getting started, and let's move into the app directory, okay? And let's create a Dockerfile in here. So then Dockerfile, and let's start to create a more complex, a little bit more complex, not too bad, but a little bit more complex Dockerfile. All right. So let's start from, don't forget insert mode, from, let's do node 12-alpine. We talked about Alpine before being a lightweight distribution of Linux. And then let's add a run command here and create a, so by the way, whenever we're adding additional lines here, it creates an additional image layer. So keep that in mind as you're adding, you can add run, but in order to keep your container image small, you want to try to either put multiple commands in one string using the ampersand, or however you want to do it, using the semicolon maybe. Or you just want to keep this, just have the command be on one line. And just to keep your image small, you just want to limit your use of the run command for each one of these. So run, let's do apk, which is the package manager for Alpine, add, and then no cache python 2 g++ make. Not really important about what that does, but just go ahead and follow along here, and we'll see what the end result will be. So workdir is going to be the /app directory, and we're going to copy. So copy dot space dot, and that means copy everything from where my Dockerfile is at into, or where my current directory is, I should say, into the current directory in the container. So copy everything basically. So here we're going to add another run yarn install production, and then cmd, and we'll do node src/index.js. So these are the commands that it's going to run when the container starts up. And then we're going to finally expose 3000. Okay, so that's a pretty complex file there. Let's see if it works. Okay, so now let's build this image. So Docker image builds, and then we'll tag this to do app, and then a dot again to indicate where the Dockerfile resides. Yeah, time is just flying. I didn't intend this to take so long, but this is really good stuff. It's really exciting. So I hope whether you're watching this live or watching this after the fact, it's good stuff. All right, so now that we've built the image, we can see Docker image ls again, and there it is, to do app. Pretty cool, right? All right, so we can run this just like we did the other one. So Docker run, run in Daemon mode, name to do, I'll name this to do app will be the name of my container. and then expose 3000 to do app. Cool. So Docker container ls, Docker container, if you spell it right. And there's our two containers. Cool beans. And all right, so the cool way to look at this this application that we just kind of turned into a container, or containerized, as they say, from here is click on this hamburger menu up in the top right-hand corner, go to traffic/ports. That'll open a new tab. So scroll down, and where it says custom ports, type in 3000 and click on access. And there it is. There's our application that we just containerized using our source code. And this is just a simple to-do app. And so we can do milk, eggs, bread. It's my shopping list. Anyways, so that's our application, and that is currently running inside of a container. Pretty cool, right? And so we talked a little bit before about so we talked a little bit before about the Dockerhub, right? And it being the default for Docker. And so let's go ahead now and Docker image ls. So we have to, in order to push this image up to Dockerhub, we have to name it in a certain way. We have to name it with our Docker username, our Dockerhub username, / and then the name of the image, which is specific, because which has to be specific because there are lots of different users on Dockerhub. All right, so let's do that. So Docker image, we already learned how to tag. So we'll do that again. Docker image tag to do app latest, which is the one that I just built. And then I'll tag this correctly so that I can push it to Dockerhub. So Chad and Crowell to do app, and then I'll just do 1.0. So now I have that image named appropriately. So now, so here's how it knows that it's going to go up to Dockerhub, right? So we can cat out .docker/config.json, and from the home directory, that is. .docker config.json. Not a slash. There we go. Nope. Oh, it is. It changed to Docker. Okay, cd docker. Or no, I named that before. Jeez, what am I talking about? Okay, where'd it go? We can use our handy dandy find option here again, like we did before. Because we know the name of the file. Docker. Or config.json was the name of the file. Okay. Well, if I installed Docker the way that we did earlier in this workshop, the config.json would have been there. Let's see if it's this one actually. Vim. Nope. Okay. Well, there's a config.json file that references Dockerhub. Okay. Maybe I have to do Docker login first. Let's do Docker login. And then this is my Dockerhub username. Login succeeded. So let's see if we see it now. Oh, there it is. Yeah, I had to log in first. I didn't know that for some reason. All right, so here's the in the .docker cat.docker config.json our sys file. Oh, from the home directory. Come on. There it is, config.json. All right, so here's all the information. Oh, I don't know if I'm supposed to show you this, but nonetheless, there it is. And there's the, when you log into Docker, it creates that config.json, and you can create many different authentications to different container registries. Okay, so yeah, main thing is Docker login before you push, because that's important. And so we can do Docker image push to do app 1.0. Okay, while that's going, I'll show you how you can, sign up for Dockerhub. It's pretty simple, I think, but let me try to log out and simulate that experience for you. So here's the splash page. Yeah, get started today for free. Go ahead and fill that out, click on sign up. If you already have an account, click on sign in, and you can sign in. Pretty easy stuff, and it's free, so why not? Okay, so that's how you create a Dockerhub account. Looks like, yep, it pushed OK. So now, there it is, to-do app. And I have successfully pushed my to-do app application up to Dockerhub. Pretty cool, huh? All right, and I didn't even have to do that from my local machine. All right, let's get moving here. My apologies for taking so long. Okay, let's talk about Docker networks. Docker networking. Fairly simple, depending on how you look at it. But the main thing is that there's this thing called a Docker bridge network. And maybe not an actual bridge, but I like to picture a bridge in my mind. It helps me kind of remember what it's doing, which is providing a pathway from your local system to the container. The bridge network is more or less accessing certain ports and protocols through a local stateless firewall on your system. And that's how, when we issue the publish command from our Docker run command, that we're able to access the container from our local machine. Okay, so there's this Docker bridge that automatically gets created when we start up Docker. So that's pretty cool. And not only that, but there's this default bridge network, but we can create additional networks too. So we can create however many virtual networks we want within the Docker network. Within that network, that will provide isolation for your containers. So for instance, if I have two containers that are both a part of the Docker bridge network, those two containers can communicate over localhost. If I have another network that has one container, it won't be able to talk to those other containers on the default bridge network. So that's a good way to isolate some of your containers. Maybe they're app-specific containers. Maybe you just want to isolate those containers to not have them be able to talk to each other. So that's a good way to do that. Okay, let's go through getting the IP address for a running container, which is pretty important. And then let's go through getting a new creating a new virtual VNet named mynet and using the bridge driver. And then we'll add the mynet virtual network to a running container. Oops. Okay, so let's do that. So let's start by looking at what container networks, what virtual networks are available for our containers. Docker container ls, container ls, there we go. And so, no, not container ls, network ls. Docker network ls tells us all the virtual networks that are available for our containers to use. So there you see the default bridge network using the bridge driver. And the difference between the drivers essentially just means, whatever it's used for. So the default one is bridge, of course, which provides a bridge from the container to your host network, but also there's a host which you can bypass all of that and directly use the host network if you want. And then there's other drivers as well. So we won't, that's beyond the scope of this course. So let's go ahead and move on. So when we go ahead and run a container, for instance, when we do Docker container run -p for publish, and let's do, oops, we already have, so let's do 8800 to 80, name proxy d Nginx. So create a container named proxy using the Nginx image and have it run in the background. We've done this quite a few times already. And so what we can do is kind of inspect that to find the IP address. And Docker has a particular format that it uses to kind of parse for this information. So just bear with me and let's do Docker container inspect. Format, and then the format is kind of wonky, but I think you've seen this other places perhaps. So .network settings .ip address, and then we have specified the container name. So this is how we kind of filter through. So we could just do Docker container inspect proxy, and we can get all this information. Or the way that we did it was we just filtered down to only get the IP address, if that makes sense. So using that format flag helps a lot when trying to search through all of that output. Docker container port is another way to find out what ports are exposed. So in this case, 8800. And we can inspect the individual networks by, let's clear and do a Docker network inspect bridge. And so this tells you what containers are a part of this virtual network. So you can see this is the bridge network. This is the subnet range that's using. Let's see. If we scroll down here, we can see Busy Williams, which is the name of a container. To-do app, that's the one that we just ran. Those are the containers that are running on this bridge network. So it's a good idea to run that command to find that. So let's create a new one, shall we? So Docker network create my_net. That creates a new Docker network. So now if we do Docker network ls, you can see there's mynet. Cool. And so we can inspect mynet if we wanted to. We just went through how to inspect. Let's do, so how to connect a running container. So we look at our running containers, Docker container ls. We have 3 running containers. So let's attach one of these to the new network that we just created. That would be fun, right? Okay, cool. So let's do Docker network connect. So this is going to connect a network name, so my net, to the container. The container name in this case is proxy. So we do that, and then we do a Docker container inspect on proxy, and then we can see, if we scroll up a little bit, the networks. So it's on the bridge network, but it's also on the mynet network. So that's a pretty cool way of essentially plugging in a new NIC for a container. And then let's see. So yeah, we can do Docker network inspect mynet, and then we could see from that side of things, what containers are running. Container name is proxy is right here, and then we can run Docker disconnect to disconnect that word, Docker network disconnect my net from proxy, and now we see it's gone. So that was a quick walkthrough of how to create a virtual network and essentially add a NIC to one of our containers by first creating a new virtual network and then kind of plugging it in so it's available on that specific network. Cool. So let's get into Docker volumes, shall we? So Docker volumes are really cool because you can not only have persistent data, which meaning data that persists beyond the life of a container, because as we know, containers are ephemeral by design. So you could use the temporary file system that's created along with the container, or you can use persistent these things in Docker called persistent volumes that will allow us to have the data persist or last longer than the container. So if the container dies, we still have that data accessible. Don't lose any data. So named volumes offer persistent storage. So there's 2 types of volumes, named volumes and bind mounts. So named volume offer persistent storage. So again, you create the volume, whatever container comes and goes, you can access that same volume. The same data will be on that volume for the life of that volume. So that's nice. And then bind mounts offer direct mapping to an exact mount point. And we'll see how this comes in handy in a second here. But yeah, so this is what it looks like. So a container comes and goes. It's able to access that volume, and the data persists. You don't lose any data because the data wasn't on the container itself. It was on a separate volume. So it's nice. Okay, so bind mounts, let's say you're working on your application, much like we did when we created that to-do app. We built that image and ran that container. Let's say you want to improve that application some bit, and you want the source code to be directly accessible to inside of the container. So what you can do is create a bind mount that binds the current directory, being the directory that your source code is in, to the container, so that it's a kind of a one-to-one relationship, so that when you modify your source code, it also gets changed in the application. So you can see your changes in real time, which is nice. And we'll go through an example of that real quick. Okay, so you can see the app changes immediately, like I said, and without having to constantly change your source code, rebuild the image, republish it, see if it works. That's a tedious process, which we can easily get around using bind mounts. Okay, so let's go through two examples. Let's create a container that uses a volume named mysql_db mounted in the container at var_lib mysql. And let's delete and create a new container to see if that data still exists, still persists. And then we'll create a bind mount directly to a local mount point. And we'll update the source code locally. So we'll make some changes to our application, and then we'll see those changes in the container immediately. Okay, so let's do it. All right, so Docker volume ls is how we look at our volumes. And because we have a couple running containers, we see that we have a couple volumes that are associated with that container. So that's nice. Let's go ahead and do as we said we were going to do and run a MySQL instance and attach a volume to it. And we'll, for this particular example, we'll attach a new volume. So in addition to those two local volumes that you see there with the crazy names, we'll create one that has a more easily readable name. Okay, so let's do Docker container run and run in the background, and we'll name it MySQL. And let's attach an environment variable again, MySQL allow empty. Before we did a random, right now we'll do empty for purposes of this demonstration. Password equals yes. So that's the environment variable. And then a -v is what we're going to want to indicate for our volume. And we're going to call our volume. We'll just give it a friendly name of mysql-db. And then again, we're going to mount that inside the container at var_lib mysql. And then we're going to use the MySQL image. We'll wait for the image to download. Might take a little bit, but while I'm waiting for that, I'll check if there's any questions. Okay. A little bit overwhelming for me, but I'm not giving up. Still trying my level best to understand the concepts. Yes, the spirit. I love the attitude and sticking with it, even though it's overwhelming. I know it can be overwhelming, but good thing this is going to be published somewhere. You can replay it multiple times. I look forward to that. Okay, please elaborate why we have to copy files and directories to the container. So why do we have to copy files and directories to the container? We don't. Maybe copy files to direct. I can't remember when we did that. We've gone so fast. Copy files and directories to the container. So files like source code, yeah, source code and things that we want to put inside of our container image to add functionality. So like I said, starting with a base image, that image may not even come with a package manager, or may not even come with curl, or may not even come with bash. Some containers don't have bash, like Alpine. So you can create a container image that uses Alpine base image and adds bash to it. So that's the neat feature on adding stuff to your images. And then as far as copying files and directories to the container, we want to copy all of our source code into the container so that we can run our application inside of the container. We don't want to add any external dependencies. So that's why we're copying all those files into the container. Like VirtualBox, does VirtualBox have bridge network connection to use a network of hosts? Yeah, yep. You can use VirtualBox to use your host network, and is very similar to what we've been doing so far. So yeah, it's essentially a bridge network. I would call it that too. So yep. All right, so now we have to move forward. So now that we have our MySQL image, MySQL container running, so let's do Docker container ls. There's our, where's our container? Where did it go? It's not running. Okie dokie dokie. Okay, Mongo, MySQL, it exited. Why did you exit, sir? Docker container run -d. Docker container run -d MySQL. I already have a MySQL, that's why. Oh my goodness. I'm just building on build. I think Docker container rm MySQL. Let's try to fix that. Container ls. No, Docker container ls-a. Okay, let's move on. If we notice, so Docker, let's do Docker volume ls again, and there's our MySQL-db friendly name for our volume that we created. And so I'm not sure what happened there, but maybe I misspelled something. But let's try this. Let's try copying and pasting directly from the MySQL allow empty password. That's the command I was trying to run. Let's try that again. Container, okay, yep. Docker rm again. Docker container rm MySQL. Oh, maybe, okay, I have to Docker container rm force, and then we'll do proxy to do app and busy Williams. Okay, so let's do, okay. Oh. Okay, well, okay, no time to troubleshoot, sorry. So, you know, the thing that I was trying to demonstrate here is if we do Docker volume ls, we have our friendly named, not with all the bits there, MySQL-db, so that's cool. So if we do, maybe I typed it wrong in my notes, so let's try this one. Hey, I did it. Not sure what I did differently there, but okay. Okay, so yeah, now it's running as I originally intended on. And so now if we do Docker volume ls again, it's utilizing the same volume. And so how do we know that? So we can do Docker container inspect, and we can do MySQL, what do we call it? 2. All right, so now we can scroll up to mount points. Where did you go? This is why grep is useful. Don't know why I'm not using it. Don't ask me. No, okay. Where are you? Mount points. Nope, I can't do that. That's why. There's the network. There's the network settings. There's the environment variable. Aha, there it is, mounts. Type volume. Oh, it's not using the same. It's not using the same one. Why is that, sir? Oh, no, it is, yeah. Var lib mysql. The source is different, though. Let's take a look at my command. Oh, there's no -v in there. Oh, my Lord. Where did I get that? Okay, so let's add the -v. Well, it's running, so. I don't know how I messed this up, sorry. So it's clear Docker container rm force and then mysql 2. Okay, let's try it again. We can do it. -v mysql -db var lib mysql. No space left on device. Okay, I gotta clean up some of these volumes. Docker volume ls. Okay, that's the thing about running containers like this. Yeah, oops. Maybe this will solve it for me. Yeah, I'll just refresh. That'll solve it for me. But yeah, as you create and delete containers, the volumes never go away. So that's something to keep in mind too. I should have mentioned that. Okay, so volume mysql db var lib mysql. Okay, we gotta wait again. Okay. There we go. Okay, Docker volume ls, clear. And then, so let's Docker container rm, and then force mysql 2. And let's run that command again. So this is a new container, same, you know, I guess we could name it something different, but I guess it doesn't matter. So Docker volume ls. Oh, same volume, didn't create a new volume, so that's good. So Docker container inspect mysql 2. And let's scroll up to the mount points. There we go. Boom, MySQL DB using the same exact volume. Gotta love it when things work out. I'm not sure what I did wrong, but maybe I will look at this video later and find out. Okay, so we still have to create a bind mount, so let's do that next. So now that we know how volumes work, we can reuse volumes, we can create friendly names for volumes, all good and well. Let's go ahead and do something cool with bind mounts. So in order to use bind mounts, it's the same kind of syntax that we use, the -v. So we'll do Docker container run in the background. We'll name it to do to do app, and we'll expose 3000 again. So this is our same to do app that we were working with before. -w, which is our working directory. We can specify that from the command line as well, which is cool. And then a cool little trick here to get your present working directory is just to put it in parentheses with a $sign. And that will prevent you from having to explicitly state where you're running this from, which can save a lot of time. So node 12-alpine is what we're going to run here. And inside of that, we're going to do a shell. And then in the shell, we want to run the command yarn install &&, and then yarn run dev. Don't worry too much about the command. Just know that we're using the -v again to do something similar to what we did before with volumes, but this is going to attach a volume, that volume being our present working directory. And then that's going to mount that into the app directory inside of the container. All right, so let's do Docker logs to do app. And we will see, we'll make sure that this is ready to go. We should see, couldn't find a package.json file. Oh, that's right. My present working directory has to have those files. So let's see, clear, and let's make that directory again. I forgot we refreshed our machine, so we got a brand new machine here. So make directory to do, cd to do, and then git clone, and then let's grab that from over here. Git clone, boom, and then paste that in. So, oops, that's gonna yell at me. Paste that in. Getting started. And now we can do that command because that was silly. Docker container ls-a, and then we'll remove that. Docker container rm to do app. Okay, try this again. Boop, boop, boo, doo, doo, doo. Go up, 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 and away. Oh, you know what? We want it to be in the app directory. Okay. To do one more time. Okay, so now that we, let's do Docker logs again to do app. Fetching packages. We're waiting for this for the command to finish basically. And we're just looking at the logs in order to do so. Linking dependencies. Coming to a resolution. Linking dependencies. Come on now. Done. Listening. All right, there we go. Okay, so let's go ahead and do vim. Oops, let's clear the screen. Vim src static, and then js, app.js. And in here, we're going to look for adding. I can search by just doing the forward / and then adding, search for whatever I want to search for. Oops, capital A. And then I'm going to change this. Instead of add item, I'm going to do add. I wonder if we have it still cached. Yeah, so add item, see the green button? Add item, we're going to change that to just add. That's all. Pretty easy stuff. So save and quit. And now what's cool about this is that we can see this change happen in real time. You know what I mean? So we can refresh this page and oops, maybe we need to establish a new session here. So all right. Since we started a new VM, it's not that easy. So we'll go to traffic ports again on our killer coda thing, and we'll type in 3000, click on access, and boom, there we go. So milk, eggs, and honey, essentials in my eyes. All right, so that's all there is to it. That's how we saw those changes in real time due to bind mounts. Bind mounts are really cool, especially for developers, right? Because you can make changes to your source code, and those changes you can see in real time, like instantly, which is cool. Okay, so now that we've gotten our app all straightened away, what we can do is do docker container stop to do app. Yep, so we can stop that container. And now that we know that it's running how we want it to, so we can do docker container ls-a, it's still there, cool. And so we can do docker image build -t. So we're gonna, since we're in the source directory, so it's so we're in the app directory, and oh, this isn't, it's not gonna have our Dockerfile, huh? So then Dockerfile, that's all. And then we'll go over here and just copy and pasta. And Dockerfiles and beginner Dockerfile. And we'll just do this. We'll copy and paste action and insert mode, paste, and then save and quit, and then docker image build again, and then -d to do app, boom. So we're rebuilding this so that all future images have that change to the to-do application. So that's pretty cool. So yeah, we can see our changes in real time. Once we're happy with them, we can rebuild our image, and obviously that is a lot faster of a way to do it. Copy failed. Oh, that's not it. That's not the right Docker file. Oh my goodness. Docker files. Now this, I think it's under. Yeah. Okay. Sorry about that. Okay. So copy that, and then go back over here and vim Dockerfile, and then we'll just do a boom, and then copy that. All right, so copy that, paste that in there. Because I have my font pumped up like that, it's getting all wonky, but trust me, it's there. Okay, so Docker image build to do app, and then actually let's do, and then what did we call it before? To do app, and then we tagged it 1.0. Let's do a 2.0. 2.0 right here. So we can kind of skip that step of having to retag our image. You can still hear me okay, right? Hopefully I'm not talking into the universe. Okay, good. Somebody verified that they're able to hear me. Okay. Yeah, we'll just wait for this to rebuild and then we can push again. I can't remember if we probably have to log in again, but that's okay. Okie dokie. All right, so we can do Docker login again. And a Docker push, Docker image.ls, Docker push. Spell my name right. To do app and then 2.0. Cool. Okay. So I hope you recognize the value of bind mounts there. So that was pretty cool. All right. So let's talk about how all of this could become much cooler with Docker Compose. So I'm going to try to. I know we've spent a lot more time than I anticipated. So apologies for that. But like I said, you can. I think this will be posted at another time, so you can come back and revisit it and replay. All right, so running multiple containers, just a note before we get into Docker Compose. Each container should be a single purpose container, right? So you shouldn't have your front end and your back end in the same container, especially not for production purposes. Decoupling containers eases the maintenance of those containers, being that you have a separation of concerns, as we say, and you're able to update them and provide maintenance to them independently. So they're kind of decoupled, and you don't have to. You can work on one without having to affect the other. Is what I'm getting at. So using Bridge Network, we can allow containers to talk on localhost. So that's the value of even though we have two containers that can still talk to each other. So we're really not losing anything when we're separating out our services into different containers. You know what I mean? So these are two different containers, the front end and the back end, and they're so happy because they're able to talk to each other. And the front end has ports exposed, the back end does not. And they're still able to essentially act just as they would if they were on the same container. So like I said, there's no there's no disadvantages here, so why not? And so this is kind of how you should be running your containers, is every single container should have a dedicated use. So do something and do it well. So yeah, Docker Compose allows us to spin up multiple containers and do that with a set of instructions, as you'll see in a common Docker Compose file that I've listed here. So this one's WordPress and MySQL. Those are two different containers, but contain the instructions for how to run those containers. So we have the environment variables and the ports and the volumes and everything that's required, so that you don't have to sit here and type in Docker container run, Docker blah, 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 blah. So all this stuff is automated to a certain extent, or scripted, I should say, using a Docker Compose file, which is built in YAML, which is always nice. YAML is our friend. All right, so image, ports, environment, just as you like it. You got a friendly name for your volume. Everything in here is pretty self-explanatory. Just swapping out the name, like containers equal services, you know what I mean? So I made that point before about each service you want to have live in a separate container, do one thing and do it well. So, you know, services equal containers in this kind of terminology that we're using here. So when we're talking about services at the very top there, we're talking about containers. In this case, we have service number 1, which is WordPress, service number 2, which is MySQL, and they're both kind of deployed together and will work together, but are two separate containers. So it's lovely. Okay, workshop number 11. Holy smokes, 11 workshops. What are you trying to do to me here, Chad? Compose, create a Docker Compose file that will script the running of 2 containers. Pretty simple, right? And then we'll run the Docker Compose up and the Docker Compose commands to do that as well. So let's see. I don't know if Docker Compose is on here. Oh, it is. Nice. Okay, we can move forward. All right, so what directory are we in here? So let's back out to our home directory. Back to our home directory. And let's go ahead and create a special little file here, and let's make a home for it. So let's do Docker Compose. Compone, that's not it. Docker Compone to Docker Compose. Okay. And so we'll do vim and then docker-compose.yaml. YAML, I'm going to take a shortcut here and copy and paste from my repository there. Oh, where is it? Docker Compose to-do app. There it is. So here's the same exact to-do app, but put in a nice little compose file. So this is awesome. Let's go over it together, shall we? All right, so GG, get to the top of my file here. Version 3.7. This is the version, the version syntax for Docker Compose itself. So I don't think this is actually needed anymore, but yeah, we put that in there anyways, just for fun. And we define a list of services that we want. Like I said, services equals containers. So kind of the next line in line with, or just under services, we have app, which is one container, and then MySQL, which is another container. So we have in our app, in our first container, in our app container, we have the image that we're going to use. So this is very much like we run the Docker run command, and then we do a dash, or no, we just specify the image at the end of the command. That's what we do. And then the command, which is the -c that we inserted before in our Docker run command. And then the ports, which is the -p, and then same syntax, so 3000 to 3000. A working directory, which is the directory that we're working in. So -w would be the command line argument for that if you're doing the docker run command. Volumes, so volumes, what volumes we want to use. And so right here is // What's //? It's our current directory, the directory that contains our application code. And then /app is the volume that's going to be inside the container. Then we have a number of environment variables: MySQL host, MySQL user, password, and DB, which is pretty cool. And now we're able to separate this out, not only in terms of in our mind, but also we're able to separate this out into its own MySQL container. MySQL is a great relational database that we can use. In this case, we're using 5.7, and we're specifying volumes that we're going to use for this. So we're using some persistent volumes, which is awesome. And then the environment variables, MySQL root password and MySQL database, relate to these, let's see, MySQL database. They're independent of the other container, as they should be. And then the volumes are the Docker volumes, Docker volume ls. We ran that before, right? Is the name of the volume that it will create. And we'll take a look at that after we run this. So let's go ahead and save and quit. And now all we have to do, this is the magical part, is we have to do, well, let's see if Docker container ls, let's delete, it's all gotten all funky on me. So let's delete this MySQL container because we're going to have some conflicts here. So let's do Docker container rm force MySQL 2 is what I called it. So I don't think we would have conflict. But container. Gotta learn how to spell container, man. All right, so the magic. Docker compose up -d to run it in the background. That's all you gotta do. Oh, come on. Insufficient runtime for containers, option command. Shorthand flag, D and D, Docker help. We gotta connect the Docker and compose, silly. Docker -compose up. Oh, so that's all. So that's a good way to automate, or script, I should say. I keep saying automate, but script your containers and multiple containers. And this list could keep going and going. You could have 500 containers in this Docker compose file if you wanted to. So that's really cool. All right, as we wait for that, let's go ahead and move on. Docker security. Okay, we're finally on to the last slide, folks. Thanks for hanging in there. Appreciate your time. I didn't really respect your time, but I apologize. I beg for forgiveness. But anyways, Docker security. Don't just run any image on the internet. That's crazy. It may contain malware. You also got to be careful as far as how containers run. Running them in rootless mode is the way to go, so that inside of a container, you're not running your commands as root inside of the container, because that means that you can gain root access to the kernel, and that's not cool. You want to scan your images for CVEs, and you want to use AppArmor or SD Linux or SDComp for locking down what a container can have access to on the host. This makes sure that you don't have that kind of barrier breakthrough that you have sometimes when you're running rootless containers. Yeah, so making sure that you're not running your containers as root, so that you can't escape into the host system and poke around. Limit what ports are accessible from each container. So that's important, because we don't want to necessarily expose everything. We want to make sure that our front end exposes the necessary ports, like 80 or 443, and then the back end exposes the necessary ports for like a database, so 3306 or something. So we want to make sure that we explicitly state that, so that we don't have ports open everywhere. And then again, separation of concerns. So this means we want to have a good identification for, um, what our apps are doing or what our containers are doing, so that we can know to expect, or however you say it, we can come to expect, that's the phrase, we can come to expect that this container should act a certain way because of what it does. You know what I mean? So if it's an Nginx container, for example, we know that it's going to be, outputting a lot of logs in terms of, traffic logs to the web server, because it's a web server and people are accessing it from the World Wide Web. So that sort of stuff. So using Bridge Network, we can allow containers to talk on local hosts. So making sure that we're isolating our containers appropriately, so we're not having hundreds of containers using the Bridge Network. We make sure we create new networks, new virtual networks, so that we can utilize the isolation techniques that those virtual networks give us. And then the security of the kernel itself, right? The container is only as secure as the underlying host kernel. Okay, so when you're thinking about running containers on whatever kernel or whatever operating system, think about the security of that. Like I think that's why Kali Linux has become so popular, is because we have security built in to the operating system. So keep that in mind as well. So you have to patch your kernel. You have to make sure that things are updated. You have to make sure that these security vulnerabilities are addressed. And then finally, the security of the Docker daemon. And then you can check all of this out to see if Docker is installed correctly and has proper, it will basically print out a report. Here, let's go over to it. So if we go over here to Docker bench, Docker bench. So let's open this guy up. And so here's another GitHub page, but essentially it'll print out this report, say, ensure only trusted users are allowed to control Docker daemon and stuff like that. So it's very, very useful in terms of making sure that Docker is configured with security in mind. So Docker bench, check that out. Okay, that's basically it. So let's wrap it up finally, folks. Thanks for hanging in there. If you're still with me, God bless you. Oh my goodness, we went so beyond the time. I apologize again for not keeping it with the confines of what I originally intended, but there we go. Hope it was helpful.
Oh, absolutely. I think everybody just loved it, and I mean the response have been crazy. People have been, telling across in the chat how they have loved each and every bit that you have explained, the storyline of the workshops, how you have divided into the structure. So everything was amazing. You went into the deep dives as well, and then all the other stuffs, the hands-on stuff, which actually was there. So it was amazing. So thank you so much,
Yeah.
Chad, for this wonderful workshop. I know it went for like 6.5 hours. Even I didn't think that it would go for so long, but it was amazing because the content that you have brought was just mind blowing. So a big thanks to you.
Yeah, appreciate it. Appreciate you allowing me to go, kind of beyond what we had originally talked about, because I think we were thinking 3 hours, and then I really just easily doubled it. I don't know how, but just time flies when you're having fun. And I think this is going to be useful for a lot of people. So I hope you get a lot out of it. Please feel free to reach out to me on the socials. And yeah, I'm a pretty nice guy, so please reach out and say hello.
Yep. So please follow Chad on the social platforms, all the social platforms, and give a shout out. And do tell about your learning, especially to the people, to the 20, 30 people who were there till the end. You need to give a shout out on how it went, what you learned, how amazing it was, how amazing Chad was. So that would be amazing. It's always encouraging for the speakers to get the feedback. So to give that, it would be amazing. And yeah, so this was the first workshop that was presented to you by Cube Simplify. And for the rest of the workshops, you need to go to cubesimplify.com/workshops. The next workshop is by me. I will be taking that on Kubernetes next week. And we will be using the same Killer Coda platform. But yeah, I know Chad has raised the bar, so I cannot guarantee to be as awesome as Chad, but I'll try my best to teach you Kubernetes next week. So
Oh, I'm
make
sure you'll do great.
Thank you. So make sure you tune in and follow Chad. And also, Chad, can you tell about your book? Please drop a link as well so that people know about your book as well.
Oh, okay, let's see. Let me type in the link.
Yep.
Let's see. Okay, so go to that link and let me give you a discount code as well. I think there's maybe a promotional thing happening right now, but let's do this. Let's do, you'll get at least 35% off if you use this code, AU35CRO. I just typed it in the chat. So use that code at checkout, get at least 35% off. I think there's a 45% off promotion going on right now, but yeah, so there's an exam called the Certified Kubernetes Administrator Exam. It's put on by the Linux Foundation. And if you'd like to take that exam, please let me know because I'd love to help you along your journey. I've written this book for people like yourself, people who you watching right now. And I really think that it's going to help a lot of people not only pass this exam, but be able to implement some of the stuff that we went through today. And kind of I'm always a learn by doing sort of person. Very hard to do in a book, by the way, but I've done my best. And so we have a lot of great examples on what you might come across when you try to take the exam and learn Kubernetes along the way. So I'm really excited about it. Thanks for supporting me if you do decide to buy a book, but if you don't, I wish you the best on the CKA if you're taking it. And yeah, please let me know.
Yep, absolutely. Thank you so much, Chad, and thank you so much, everyone who has stick till the end. And obviously, people will be watching it later. I know, like 6 hours, 6.5 hours sitting straight is not an easy task. So I hope we'll be kind of try to break down the workshops and see what all we can do with it to give you the best. So that you can go through each sections one by one, or at different areas. Be sure to check out cubesimplify.com/workshops, because there are, for the next kind of couple of months, this will keep going on each week, every week, and there'll be tons of knowledge dropping on you. So kind of you only have 1 week to practice Linux and Docker, because next week it will be all Kubernetes. So I hope you enjoyed today's workshop. Give a shout out to Cube Simplify Chad, for bringing these to you, and see you next time. And thank you so much, Chad, for joining us live.
Yeah, thank you. Thanks, everyone. Bye-bye.
Bye.